Hey, this is Andrew Brown, and I'm bringing you another certification course, and this time it's the Azure AI Fundamentals, also known as the AI-900. And if you're looking to pass the certification, we have everything that you need here, such as labs, lectures, and a free practice exam, so you can go ace that exam, get that certification, put it on your resume and LinkedIn to go get that job you've been looking for. If you want to support more free courses like this one, the best way is to purchase the additional paid materials where you can get access to more practice exams and other resources. If you don't know me, I've taught a bit of everything here on the cloud. That's been with AWS, Azure, GCP, DevOps, Terraform, Kubernetes, you name it, I've taught it. But you know the drill here. Let's get into it and learn more about the Azure AI Fundamentals. Hey, this is Andrew Brown from ExamPro, and we are at the start of our journey here learning about the AI-900, asking the most important question, which is, what is the AI-900? So the Azure AI Fundamentals Certification is for those seeking an ML role such as AI engineer or data scientist. The certification will demonstrate if a person can define and understand Azure AI services such as cognitive services and Azure Applied AI services, AI concepts, knowledge mining, responsible AI, basics of ML pipelines, classical ML models, AutoML, Generative AI Workloads, which is newly added content, and Azure AI Studio, so you don't need to know super complicated ML knowledge here, but it definitely helps to get you through there. So this certification is generally referred to by its course code, the AI-900, and it's the natural path for the Azure AI Engineer or Azure Data Scientist certification. This generally is an easy course to pass, and it's great for those new to cloud or ML-related technology. Looking at our roadmap, you might be asking, okay, well, what are the paths and what should I learn first? So here are a few suggested routes. If you already have your AZ-900, that's a great starting point before you take your AI-900. If you don't have your AZ-900, you can jump right into the AI-900, but I strongly recommend you go get that AZ-900 because it gives you general foundational knowledge. It's just another thing that you should not have to worry about, which is just how to use Azure at a fundamental level. Do you need the DP-900 to take the AI-900? No, but a lot of people seem to like to go this route where they want to have that data foundation before they move on to the AI-900 because they know that the broad knowledge is going to be useful there. So it's a pairing that you see a lot of people getting, the AI-900 and the DP-900 together. For the AI-900, the path is a little bit more clear. It's either going to be data scientists or AI engineer. So for the AI engineer, you have to know how to use the AI services in and out. For data scientists, it's more focused on setting up actual pipelines and things like that within Azure machine learning, so you just have to decide which path is for you. The data scientist is definitely harder than the AI engineer, so if you aren't ready for the data science, some people like taking the AI engineer first and then doing the data scientist, so this is kind of like a warm-up. Again, it's not 100% necessary, but it's just based on your personal learning style, and a lot of times people like to take the data engineer after the data scientist just to round out their complete knowledge. Now, if you already have the AZ-900 and the administrator associate, you can safely go to the data scientist if you want to risk it because this one is really hard. So if you've passed the AZ-104, you know you're going to probably have a lot more confidence learning up about all the concepts at this level here. But of course, it's always recommended to go grab these foundational certs because sometimes course materials just do not cover the information, and so the obvious stuff is going to get left out, okay? So moving forward here, how long should you study to pass for the AI-900? If you're entirely new to ML, AI, and cloud providers such as Azure, you should anticipate dedicating around 15 hours to grasp the basics. This estimate can vary based on your familiarity with these concepts. For complete beginners, the time commitment might extend to 20 to 30 hours. For the intermediate level, so people that have passed the AZ-900 or DP-900, you're looking at around 8 to 10 hours. If you have 1 or more years of experience with Azure or another cloud service provider like AWS or GCP, you're looking at about 5 hours or less. The average study time is about 8 hours. This is where you should be committing 50% of the time to the lecture and labs and 50% for the practice exams. The recommended study time is 30 minutes to an hour a day for 14 days. This should get you through it, but just don't overstudy and just don't spend too little time. What does it take to pass the exam? Well, you got to watch the lectures and memorize key information. Do hands-on labs and follow along with your own Azure account. I'd say that you could probably get away with just watching all the videos in this one without having to do the labs. But again, it really does reinforce that information. If you do take the time, there is some stuff that is in Azure AI Studio or machine learning. You might be wary of launching instances because we do have to run instances and they will cost money unless you delete the instances after use, resulting in very small costs. So if you feel that you're not comfortable with that, by just watching the videos, you should be okay. But when you get into the associate tier, you absolutely have to expect to pay something to learn and take that risk. You want to do paid online practice exams that simulate the real exam. As I've mentioned before, I do provide a free practice exam and have paid practice exams that accompany this course that are on my platform, ExamPro, and that's how you can help support more of these free courses. So, can you pass this certification without taking a practice exam? Well, Azure's a little bit harder. If this is an AWS exam, I would say yes, but for Azure exams like AI-900, DP-900, and SC-900, probably not. It's kind of risky. I think you should do at least one practice exam or go through the sample one. There's a sample one probably laying around on the Azure website. Let's take a look at the exam guide breakdown here, and then in the following video we'll look at it in more detail so it's broken down into the following domain. So the exam has 5 domains of questions, and each domain has its own weighting, which determines how many questions in a domain that will show up. So 15 to 20% will be describe AI workloads and considerations. 20 to 25% will consist of describe fundamental principles of machine learning on Azure. 15 to 20% will consist of describe features of computer vision workloads on Azure. 15 to 20% will be describe features of natural language processing workloads on Azure. And 15 to 20% will be describe features of generative AI workloads on Azure. I want you to notice it says describe these domains. This is good because that tells you it's not going to be super hard. If you start seeing things that say beyond describe and identify, then you know it's going to be a bit harder. So where do you take this exam? Well, you can take it in person at a test center or online from the convenience of your own home. So there's 2 popular test centers, there's Certiport and there's Pearson VUE. You can also take it at a local test center if there are nearby locations. The term proctored means a supervisor or person that is monitoring you while you're taking the exam. If I had the option between in-person or online, I would always choose the in-person because it's a controlled environment and it's way less stressful. Online, there are many things that can go wrong, but it's up to your personal preference and your situation. The passing grade here is 700 out of 1,000, so that's around 70%. I would say around because you could possibly fail with 70% because these things work on scaled scoring for response types. There's about 37 to 47 questions, and you can afford to get about 10 to 13 questions wrong. So some questions are worth more than 1 point. Some questions cannot be skipped. And the format of questions can be multiple choice, multiple answer, drag and drop, and hot area. There shouldn't be any case studies for foundational level exams. And there's no penalty for wrong questions. So for the duration, you get 1 hour, that means about 1 minute per question. The time for this exam is 60 minutes. Your seat time is 90 minutes. Seat time refers to the amount of time that you should take to allocate for that exam. So this includes time to review the instructions, read and accept the NDA, complete the exam, and provide feedback at the end. This certification is going to be valid forever and it does not expire. Microsoft fundamental certifications such as the AZ-900 or MS-900 do not expire as long as the technology is still available or relevant. So we'll proceed to the full exam guide now. Hey, this is Andrew Brown from ExamPro, and what we've pulled up here is the official exam outline on the Microsoft website. If you want to find this yourself, you just have to type in AI-900 Azure or Microsoft. You should be able to easily find it. The page looks like this. What I want you to do is scroll on down because we're looking for the AI-900 study guide, and from there we're going to scroll on down to the skills measured section. And you might want to bump up the text. Azure loves updating their courses with minor updates that don't generally affect the outcome of the study here, but it does get a lot of people worried because they always say, well, is your course out of date? So no, they're just making minor changes because they'll do this like 5 times a year. And so if there was a major revision, what would happen is they would change it so instead of being the AI-900, it'd be like the AI-901 or 902, similar to how the AI-102 was previously AI-100, but now it's the AI-102, so just watch out for those, and if it's a major revision, then yes, it would probably need a completely new course. So there aren't any major changes with the new update, other than the update for the Generative AI Workloads on Azure section, a couple of name changes, and a few things being removed. Everything else remains relatively the same, with very minor changes, so the concepts and such are still up to date. Overall, I think the exam is easier than before. So let's go through some of the topics and work our way through here. So describe AI workloads and considerations. So here we're just kind of describing the generalities of AI. So, content moderation workloads involve filtering out inappropriate or harmful content from user-generated inputs, ensuring a safe and positive user experience. Personalization workloads analyze user behavior and preferences to tailor content, recommendations, or experiences to individual users. Computer vision workloads involve the analysis of images and videos to recognize patterns, objects, faces, and actions. Identify natural language processing, knowledge mining, document intelligence, and features of generative AI workloads. Note that these are all just concepts. You don't need to know how to use the services at a high level. Then you have the responsible AI section. So Microsoft has these 6 principles that they really want you to know, and they push it throughout all their AI services. So those are the 6 you'll need to know, and they're not that hard to learn. Moving on, we have described fundamental principles of machine learning on Azure. So here it's just describing regression, classification, clustering, and features of deep learning. We have a lot of practical experience with these in the course, so you will understand at the end what these are used for. Next, we have core machine learning concepts. We can identify features and labels in a data set, so that's the data labeling service. Describe how training validation data sets are used in machine learning, so we'll touch on that. Describe capabilities of automated machine learning. AutoML simplifies building and picking the best models, while data and compute services provide the power you need for training. With Azure Machine Learning, it helps with managing and deploying your models, letting you put your machine learning projects into action smoothly. Under computer vision workloads, we have image classification, object detection, optical character recognition, facial detection, and facial analysis solutions. Next, we have Azure AI Vision, Azure AI Face Detection, and Azure AI Video Indexer. The Azure AI services encompass a wide range of tools designed to facilitate the development of intelligent applications. These services used to be called Computer Vision, Custom Vision, Face Service, and Form Recognizer, but have evolved or been grouped under broader service categories to streamline their application and integration into projects. For NLP, we have key phrase extraction, entity recognition, sentiment analysis, language modeling, speech recognition. Synthesis, this one doesn't really appear much. It's kind of a concept, not so much something we have to do. And then there's translation. So now we have Azure tools and services for NLP workloads. These include the Azure AI Language Service, Azure AI Speech Service, and Azure AI Translator Service. These used to be separate services, I believe, like the Text Analytics Service, Lewis Speech Service, and Translator Text Service, but they have been added to the Azure AI umbrella of AI services. And now we'll be moving on to the generative AI workloads on Azure. We'll be covering features of generative AI models, common scenarios for generative AI, and responsible AI considerations for generative AI, and also some of the cool features that Azure OpenAI Service has to offer, such as natural language generation, code generation, and image generation. So that's about a general breakdown of the AI-900 exam guide. Hey, this is Andrew Brown from ExamPro, and we are looking at the layers of machine learning. So here I have this thing that looks like kind of an onion, and what it is, it's just describing the relationship between these ML terms related to AI, and we'll just work our way through here, starting at the top. So artificial intelligence, also known as AI, is when machines that perform jobs that mimic human behavior. So it doesn't describe how it does that, but it's just the fact that that's what AI is. One layer underneath, we have machine learning, so machines that get better at a task without explicit programming. Then we have deep learning. So these are machines that have an artificial neural network inspired by the human brain to solve complex problems. And if you're talking about someone that actually assembles either ML or deep learning models or algorithms, that's a data scientist. So a person with multidisciplinary skills in math, statistics, predictive modeling, machine learning to make future predictions. So what you need to understand is that AI is just the outcome, right? And so AI could be using ML underneath, or deep learning, or a combination of both, or just if-else statements, okay? All right, so let's take a look here at the key elements of AI. So AI is the software that imitates human behaviors and capabilities, and there are key elements according to Azure or Microsoft as to what makes up AI. So let's go through this list quickly here. So we have machine learning, which is the foundation of an AI system that can learn and predict like a human. You have anomaly detection, so detect outliers or things out of place like a human. Computer vision, be able to see like a human. Natural language processing, also known as NLP, be able to process human languages and infer context, like a human. Conversational AI, be able to hold a conversation with a human. So, I wrote here according to Microsoft and Azure, because, the global definition is a bit different, but I just wanted to put this here because I've definitely seen this as an exam question, and so we're going to have to go with Azure's definition here, okay? Let's define what is a dataset. So a dataset is a logical grouping of units of data that are closely related to or share the same data structure. And there are publicly available datasets that are used in learning of statistics, data analytics, and machine learning. I just want to cover a couple here. So the first is the MNIST database, so images of handwritten digits used to test, classify, cluster image processing algorithms, commonly used when learning how to build computer vision ML models to translate handwriting into digital text. So it's just a bunch of handwritten numbers and letters. And then another very popular data set is the Common Objects in Context COCO dataset. So this is a dataset which contains many common images using a JSON file, COCO format, that identify objects or segments within an image. And so this data set has a lot of stuff in it. So object segmentations, recognition in context, super pixel stuff segmentation. They have a lot of images and a lot of objects. So there's a lot of stuff in there. So why am I talking about this, and in particular COCO data sets? Well, when you use Azure Machine Learning Studio, it has a data labeling service. And the thing is that it can actually export out into COCO formats. That's why I wanted you to get exposure to what COCO was. And the other thing is that when you're building out Azure machine learning pipelines, they actually have open data sets, which we'll see later in the course, that shows you that you can just use very common ones. And so you might see MNIST and the other one there. So I just wanted to get you some exposure, okay? Let's talk about data labeling. So this is the process of identifying raw data, so images, text files, videos, and adding one or more meaningful and informative labels to provide context so a machine learning model can learn. So with supervised machine learning, labeling is a prerequisite to produce training data, and each piece of data will generally be labeled by a human. The reason why I say generally here is because with Azure's data labeling service, they can actually do ML-assisted labeling. So with unsupervised machine learning, labels will be produced by the machine and may not be human readable. And then one other thing I want to touch on is the term called ground truth. So this is a properly labeled data set that you can use as the objective standard to train and assess a given model, is often called ground truth. The accuracy of your trained model will depend on the accuracy of your ground truth. Now, using Azure's tools, I never see them use the word ground truth. I see that a lot in AWS, and even this graphic here is from AWS. But I just want to make sure you are familiar with all that stuff, okay? Let's compare supervised, unsupervised, and reinforcement learning. Starting at the top, we got supervised learning. This is where the data has been labeled for training, and it's considered task-driven because you are trying to make a prediction, get a value back. So when the labels are known and you want a precise outcome, when you need a specific value returned, and so you're going to be using classification and regression in these cases. For unsupervised learning, this is where data that has not been labeled, the ML model needs to do its own labeling. This is considered data-driven. It's trying to recognize a structure or a pattern. And so this is when the labels are not known and the outcome does not need to be precise when you're trying to make sense of data. So you have clustering, dimensionality reduction, and association. If you've never heard this term before, the idea is it's trying to reduce the amount of dimensions to make it easier to work with the data. So make sense of the data, right? We have reinforcement learning. So this is where there is no data, there's an environment, and an ML model generates data and makes many attempts to reach a goal. So this is considered decisions driven. And so this is for game AI, learning tasks, robot navigation. When you've seen someone code a video game that can play itself, that's what this is. If you're wondering, this is not all the types of machine learning. And these in specific, unsupervised and supervised is considered classical machine learning because they heavily rely on statistics and math to produce the outcome, but there you go. So what is a neural network? Well, it's often described as mimicking the brain. It's a neuron or node that represents an algorithm. So data is inputted into a neuron, and based on the output, the data will be passed to one of many connected neurals. The connections between neurons is weighted. I really should have highlighted that one. That's very important. The network is organized into layers. There will be an input layer, one to many hidden layers, and an output layer. So here's an example of a very simple neural network. Notice the NN. A lot of times you'll see this in ML as an abbreviation for neural networks, and sometimes neural networks are just called neural nets. So just understand that's the same term here. What is deep learning? This is a neural network that has 3 or more hidden layers. It's considered deep learning because at this point it's not human readable to understand what's going on within those layers. What is forward feed? So neural networks where they have connections between nodes that do not form a cycle, they always move forward. So that just describes a forward pass through the network. You'll see FNN, which stands for forward feed neural network, just describe that type of network. Then there's back propagation, which are in forward feed networks. This is where we move backwards through the neural net, adjusting the weights to improve the outcome on next iteration. This is how a neural net learns. The way the back propagation knows to do this is that there's a loss function, so a function that compared the ground truth to the prediction to determine the error rate, how bad the network performs. So when it gets to the end, it's going to perform that calculation, and then it's going to do its back propagation and adjust the weights. Then you have activation functions. I'm just going to clear this up here. So activation functions, they're an algorithm applied to a hidden layer node that affects connected output. So for this entire hidden layer, they'll all have the same one here, and it just kind of affects how it learns and like how the weighting works. So it's part of back propagation and just the learning process. There's a concept of dense. So when the next layer increases the amount of nodes, and you have sparse. So when the next layer decreases the amount of nodes, anytime you see something going from a dense layer to a sparse layer, that's usually called dimensionality reduction, because you're reducing the amount of dimensions, because the amount of nodes in your network determines the dimensions you have. Okay. What is a GPU? Well, it's a general processing unit that is specially designed to quickly render high-resolution images and videos concurrently. GPUs can perform parallel operations on multiple sets of data, so they are commonly used for non-graphical tasks such as machine learning and scientific computation. So a CPU has an average of 4 to 16 processor cores. A GPU can have thousands of processor cores, so something that has 4 to 8 GPUs could have as many as 40,000 cores. Here's an image I grabbed right off the NVIDIA website, and so it really illustrates very well how this would be really good for machine learning or neural networks, because neural networks have a bunch of nodes. They're very repetitive tasks. If you can spread them across a lot of cores, that's going to work out really great. So GPUs are suited for repetitive and highly parallel computing tasks such as rendering graphics, cryptocurrency mining, deep learning, and machine learning. We're talking about CUDA. Before we can, let's talk about what NVIDIA is. So NVIDIA is a company that manufactures graphical processing units for gaming and professional markets. If you play video games, you've heard of NVIDIA. So what is CUDA? It is the Compute Unified Device Architecture. It is a parallel computing platform and API by NVIDIA that allows developers to use CUDA-enabled GPUs for general purpose computing on GPUs, so GPGUs. All major deep learning frameworks are integrated with NVIDIA Deep Learning SDK. The NVIDIA Deep Learning SDK is a collection of NVIDIA libraries for deep learning. One of those libraries is the CUDA Deep Neural Network Library, so CUDNN. So CUDA or CUDNN provides highly tuned implementations for standard routines such as forward and back convolution. Convolution is really great for computer vision, pooling, normalization, activation layers. So, you know, in the Azure certification for the AI-900, they're not going to be talking about CUDA, but if you understand these two things, you'll understand why GPUs really matter, okay? All right, let's get a easy introduction into machine learning pipelines. So this one is definitely not an exhaustive one, and we're definitely going to see more complex ones throughout this course, but let's get to it here. So starting on the left-hand side, we might start with data labeling. This is very important when you're doing supervised learning, because you need to label your data so that the ML model can learn by example during training. This stage and the feature engineering stage is considered pre-processing because we are preparing our data to be trained for the model. When we move on to feature engineering, the idea here is that ML models can only work with numerical data, so you'll need to translate it into a format that it can understand. So extract out the important data that the ML model needs to focus on. Okay? Then there's the training step. So your model needs to learn how to become smarter. It will perform multiple iterations, getting smarter with each iteration. You might also have a hyperparameter tuning step here. It says tuning, but it should say tuning. But the ML model can have different parameters. So you can use ML to try out many different parameters to optimize the outcome. When you get to deep learning, it's impossible to tweak the parameters by hand. So you have to use hyperparameter tuning. Then you have serving, sometimes known as deploying. But when we say deploy, we talk about the entire pipeline, not necessarily just the ML model step. So we need to make an ML model accessible. So we serve it by hosting it in a virtual machine or container. When we're talking about Azure machine learning, it's either going to be an Azure Kubernetes service or Azure container instance. And you have inference. So inference is the act of requesting to make a prediction. So you send your payload with either CSV or whatever, and you get back the results. You have a real-time endpoint and batch processing. So real-time is just batch can be real-time as well, but generally it's slower. But the idea is that am I making a single item prediction, or am I giving you a bunch of data at once? And again, this is a very simplified ML pipeline. I'm sure we'll revisit an ML pipeline later in this course. So let's compare the terms forecasting and prediction. So forecasting, you make a prediction with relevant data. It's great for analysis of trends, and it's not guessing. And when you're talking about prediction, this is where you make a prediction without relevant data. You use statistics to predict future outcomes. It's more of guessing, and it uses decision theory. So imagine you have a bunch of data, and the idea is you're going to infer from that data, okay, maybe it's A, maybe it's B, maybe it's C. And for prediction, you don't have really much data, so you're going to have to kind of invent it. And the idea is that you'll figure out what the outcome is there. These are extremely broad terms, but just so you have a high-level view of these two things, okay? So what are performance or evaluation metrics? Well, they are used to evaluate different machine learning algorithms. So the idea is, when your machine learning makes a prediction, these are the metrics you're using to evaluate to determine, is your ML model working as you intended? So for different types of problems, different metrics matter. This is absolutely not an exhaustive list. I just want you to get you exposure to these words and things so that when you see them, you go, okay, I'll come back here and refer to this. But lots of these, it's not necessarily to remember, but classification metrics you should know. So classification, we have accuracy, precision, recall, F1 score, ROC, and AUC. For regression metrics, we have MSC, RMSCE, MAE. Ranking metrics, we have MMR, DCG, NDCG. Statistical metrics, we have correlation. Computer vision metrics, we have PSNR, SSIM, IOU. NLP metrics, we have perplexity, BLUE, Meteor, Rogue. Deep learning related metrics, we have inception score. I cannot say this person's name, or I'm assuming it's a person, but this inception distance. And there are two categories of evaluation metrics. We have internal evaluation, so metrics used to evaluate the internals of an ML model, so accuracy, F1 score, precision, recall. I call them the famous four, used in all kinds of models. And external evaluation metrics used to evaluate the final prediction of an ML model. So yeah, don't get too worked up here. I know that's a lot of stuff. The ones that matter, we will see again, okay? Well, let's take a look at Juypter Notebooks. So these are web-based applications for authoring documents that combine live code, narrative text, equations, visualizations. So if you're doing data science or you're building ML models, you absolutely are going to be working with Juypter Notebooks. They're always integrated into cloud service providers' ML tools. So Juypter Notebook actually came about from IPython. So IPython is the precursor of it, and they extracted that feature out. It became Juypter Notebook. IPython is now a kernel to run Python. So when you execute out Python code here, it's using IPython, which is just a version of Python. Juypter Notebooks were overhauled and better integrated into an IDE called Jupyter Labs, which we'll talk about here in a moment. And you generally want to open notebooks in labs. The legacy web-based interface is known as Jupyter Classic Notebooks. So this is what the old one looks like. You can still open them up, but everyone uses Jupyter Labs now, okay? So let's talk about Jupyter Labs. Jupyter Labs is the next generation web-based user interface. All familiar features of the classic Jupyter Notebook is in a flexible, powerful user interface. It has notebooks, a terminal, a text editor, a file browser, rich outputs. Jupyter Labs will eventually replace the classic Jupyter Notebooks. So there you go. We keep mentioning regression, but let's talk about it in more detail here so we kind of understand the concept. So regression is the process of finding a function to coordinate a labeled data set. Notice it says labeled. That means it's going to be for supervised learning into a continuous variable number. So another way to say it is predict this variable in the future. So the future is just means like that continuous variable. It doesn't have to be time, but that's just a good example of regression. So what will the temperature be next week? So will it be 20 Celsius? How would we determine that? Well, we would have vectors, so dots, that are plotted on a graph that has multiple dimensions. The dimensions could be greater than just X and Y. You could have many. And then you have a regression line. This is the line that's going through our data set. And that's going to help us figure out how to predict the value. So how would we do that? Well, we would need to calculate the distance of a vector from the regression line, which is called an error. And so different regression algorithms use the error to predict different future variables. So just to look at this graphic here, so here's our regression line, and here is a dot, like a vector, a piece of information. And this distance from the line, the actual distance is what we're going to use in our ML model to figure out if we were to plot another line up here, right? You know, we would compare this line to all the other lines, okay? And that's how we'd find similarity. And what we'll commonly see for this is mean squared error, root mean squared error, mean absolute error. So MSE, MRSE, and MAE, okay? Let's take a closer look at the concepts of classification. So classification is the process of finding a function to divide a labeled data set. So again, this is supervised learning into classes or categories. So predict a category to apply to the inputted data. So will it rain next Saturday? Will it be sunny or rainy? So we have our data set, and the idea is we're drawing through this a classification line to divide the data set. So regression, we're measuring the line to, or the vectors to the line. And this one is just what side of the line is it on. If it's on this side, then it's sunny. If it's on this side, it's rainy, okay? For classification algorithms, we got logistic regression, decision trees, random forests, neural networks, naive Bayes, K nearest neighbor, also known as KNN, and support vector machines, SVMs, okay? Let's take a closer look at clustering. So clustering is the process of grouping unlabeled data. So unlabeled data means it's unsupervised learning based on similarities and differences. So the outcome could be group data based on similarities or differences. I guess it's the same description up here. But imagine we have a graph and we have data, and the idea is we draw boundaries around that to see similar groups. So maybe we're recommending purchases to Windows computers or recommending purchase to Mac computers. Now, remember, this is unlabeled data, so the label is being inferred, or they're just saying these things are similar, right? So clustering algorithms, we got k-means, k-medoids, a density-based hierarchical, okay? Hey, this is Andrew Brown from ExamPro, and we're looking at the confusion matrix, and this is a table to visualize the model predictions, the predicted versus the ground truth labels, the actual, also known as an error matrix, and they are useful for classification problems to determine if our classification is working as we think it is. So imagine we have a question, how many bananas did this person eat or these people eat? And so we have this kind of box here where we have predicted versus actual, and it's really comparing the ground truth and what the model predicted, right? And so on the exam, they'll ask you questions like, okay, well, imagine that, and they might not even say yes or no, maybe like 0 and 1. And so what they're saying is, you know, imagine you want to tell us the true positives, right? And so the idea is they won't show you the labels here, but you know 1 and 1 would be a true positive, and 0 and 0 would be a false negative. Okay. Another thing they'll ask you about these confusion matrices is the size of them. So the idea is that we're looking right now at a, oops, just going to erase that there, but we're looking at a binary classifier because we have one label and just two labels, right? 1 and 2. Okay, but you could have three, say 1, 2, and 3. So how would you calculate that? Well, there would just be a third cell over here, and it's just going to be actual and predicted because we're only going to have ground truth versus prediction. And so that's how you'll know it will be 6. The size will be 6. Might not say cells, but it'll just say 6. Okay. So to understand anomaly detection, let's define quickly what is an anomaly. So an abnormal thing that is marked by deviation from the norm or standard. So anomaly detection is the process of finding outliers within a dataset called an anomaly. So detecting when a piece of data or access patterns appear suspicious or malicious. So use cases for anomaly detection can be data cleaning, intrusion detection, fraud detection, system health monitoring, event detection and sensor networks, ecosystem disturbances, detection of critical and cascading flaws. Anomaly detections by hand is a very tedious process, so using ML for anomaly detection is more efficient and accurate. And Azure has a service called Anomaly Detector, detects anomalies in data to quickly identify and troubleshoot issues. So computer vision is when we use machine learning neural networks to gain high-level understanding of digital images or videos. So for computer vision deep learning algorithms, we have convolutional neural networks. These are for image and video recognition. They're inspired after how the human eye actually processes information and sends it back to the brain to be processed. You have recurrent neural networks, RNNs, which are generally used for handwriting recognition or speech recognition. Of course, these algorithms have other applications, but these are the most common use cases for them. For types of computer vision, we have image classification. So look at an image or video and classify its place in a category. Object detection. So identify objects within an image or video and apply labels and location boundaries. Semantic segmentation. So identify segments or objects by drawing pixel masks around them. So great for objects and movement. Image analysis. So analyze an image or video to apply descriptive context labels. So maybe an employee is sitting at a desk in Tokyo would be something that image analysis would do. Optical character recognition, or OCR, find text in images or videos and extract them into digital text for editing. Facial detection, so detect faces in a photo or video and draw a location boundary and label their expression. So for computer vision, just some things around Azure or Microsoft services, there's one called Seeing AI. It's an AI app developed by Microsoft for iOS. And so you use your device camera to identify people and objects, and the app audibly describes those objects for people with visual impairments. It's totally free if you have an iOS app. I have an Android phone, so I cannot use it, but I hear it's great. Some of the Azure Computer Vision service offerings is computer vision, so analyze images and videos, extract descriptions, tags, objects, and text. Custom vision, so custom image classification, object detection models using your own images. Face, so detect and identify people and emotions in images. Form recognizer, so translate, scan documents into key value or tabular editable data. So natural language processing, also known as NLP, is machine learning that can understand the context of a corpus being a body of related text. So NLPs enable you to analyze and interpret text within documents and email messages, interpret or contextualize spoken tokens. So for example, maybe customer sentiment analysis, whether a customer is happy or sad, synthesize speech, so a voice assistant talking to you, automatically translate spoken or written phrases and sentences between languages, interpret spoken or written commands and determine appropriate actions. A very famous example for a voice assistant specifically, or virtual assistant for Microsoft, is Cortana. It uses the Bing search engine to perform tasks such as setting reminders and answering questions for the user. And if you're on a Windows 10 machine, it's very easy to activate Cortana by accident. When we were talking about Azure's MLP offering, we have text and analytics, so sentiment analysis to find out what customers think, find topic relevant phrases using key phrase extraction, identify the language of the text with language detection, detect and categorize entities in your text with named entity recognition. For translator, we have real-time text translation, multi-language support. For speech service, we have transcribe audible speech into readable, searchable text. And then we have language understanding, also known as LUIS, natural language processing service that enables you to understand human language in your own application, website, chatbots, IoT device, and more. When we talk about conversational AI, it generally uses NLP. So that's where you'll see that overlap next, okay? Let's take a look here at conversational AI, which is technology that can participate in conversations with humans. So we have chatbots, voice assistants, and interactive voice recognition systems, which is like the second version to interactive voice response systems. So you know when you call in and they say, press these numbers, that is a response system, and a recognition system is when they can actually take human speech and translate that into action. So the use cases here would be online customer support, replaces human agents for replying about customer FAQs, maybe shipping questions, anything about customer support. Accessibility, so voice operated UI for those who are visually impaired. HR processes, so employee training, onboarding, updating employee information. I've never seen it used like that, but that's what they say is a use case. Healthcare, accessible, affordable healthcare. So maybe you're doing a claim process. I've never seen this, but maybe in the US where you do more of your claims and everything is privatized, it makes more sense. Internet of Things, so IoT devices, so Amazon Alexa, Apple Siri, Google Home, and I suppose Cortana, but it doesn't really have a particular device, so that's why I didn't list it there. Computer software, so autocomplete search on phone or desktop, so that would be Cortana, something it could do. For the two services that are around conversational AI, for Azure, we have QnA Maker, so create a conversational question and answer bot from your existing content, also known as a knowledge base. And Azure Bot Service, intelligent serverless bot service that scales on demand, used for creating, publishing, managing bots. So the idea is you make your bot here, and then you deploy it with this, okay? Let's take a look here at Responsible AI, which focuses on ethical, transparent, and accountable uses of AI technology. Microsoft puts into practice responsible AI via its 6 Microsoft AI principles. This whole thing is invented by Microsoft, and so, you know, it's not necessarily a standard, but it's something that Microsoft is pushing hard to have people adopt, okay? So the first thing we have is fairness. So this is an AI system which should treat all people fairly. We have reliability and safety. An AI system should perform reliably and safely. Privacy and security. AI systems should be secure and respect privacy. Inclusiveness. AI systems should empower everyone and engage people. Transparency. AI systems should be understandable. Accountability. People should be accountable for AI systems. And we need to know these in greater detail. So we're going to have a short little video on each of these, okay? The first on our list is fairness. So AI systems should treat all people fairly. So an AI system can reinforce existing societal stereotypical bias can be introduced during the development of a pipeline. So an AI system that are used to allocate or withhold opportunities, resources, or information in domains such as criminal justice, employment and hiring, finance, and credit. So an example here would be an ML model designed to select a final applicant for hiring pipeline without incorporating any bias based on gender, ethnicity, or may result in an unfair advantage. So Azure ML can tell you how each feature can influence a model's prediction for bias. One thing that could be of use is FairLearn. So it's an open source Python project to help data scientists to improve fairness in the AI systems. At the time I made this course, a lot of their stuff is still in preview. So, you know, the fairness component is not 100% there, but it's great to see that they're getting that along, okay? So we are on to our second AI principle for Microsoft, and this one is AI systems should perform reliably and safely. So AI software must be rigorously tested to ensure they work as expected before release to the end user. If there are scenarios where AI is making mistakes, it is important to release a report quantified risks and harms to end users so they are informed of the shortcomings of an AI solution. Something you should really remember for the exam. They'll definitely ask that. AI, where concern for reliability and safety for humans is critically important. Autonomous vehicles, health diagnosis, suggestions, prescriptions, and autonomous weapon systems. They didn't mention this in their content, and I was just like doing some additional research. And I'm like, yeah, you really don't want mistakes when you have automated weapons, or ethically, you shouldn't have them at all. But hey, that's just how the world works. But yeah, this is this category here. We're on to our third Microsoft AI principle. AI systems should be secure and respect privacy. So AI can require vast amounts of data to train deep machine ML models. The nature of an ML model may require personally identifiable information, so PIIs. It is important that we ensure protection of user data, that it is not leaked or disclosed. In some cases, ML models can be run locally on a user's device, so their PIIs remain on their device, avoiding the vulnerability. This is like edge computing, so that's the concept there. AI security principles to detect malicious actors, so data origin and lineage, data use internal versus external, data corruption considerations, anomaly detection. So there you go. We're on to the fourth Microsoft AI principle. So AI systems should empower everyone and engage people. If we can design AI solutions for the minority of users, they can design AI solutions for the majority of users. So when we're talking about minority groups, we're talking about physical ability, gender, sexual orientation, ethnicity, other factors. This one's really simple. In terms of practicality, it doesn't 100% make sense, because if you've worked with groups that are deaf and blind, developing technology for them, a lot of times they need specialized solutions. But the approach here is that, you know, if we can design for the minority, we can design for all. That is the principle there. So that's what we need to know, okay? Let's take a look here at transparency. So AI systems should be understandable. So interpretability and intelligibility is when the end user can understand the behavior of UI. So transparency of AI systems can result in mitigating unfairness, help developers debug their AI systems, gaining more trust from our users. Those who build AI systems should be open about why they're using AI, open about the limitations of the AI systems. Adopting an open source AI framework can provide transparency, at least from a technical perspective, on the internal workings of an AI system. We are on to the last Microsoft AI principle here. People should be accountable for AI systems. So the structure put in place to consistently enacting AI principles and taking them into account. AI systems should work within frameworks of governments, organizational principles, ethical and legal standards that are clearly defined. Principles guide Microsoft on how they develop, sell, and advocate when working with third parties, and this push towards regulation towards AI principles. So this is Microsoft saying, hey, everybody adopt our model. There aren't many other models, so I guess it's great that Microsoft is taking the charge there. I just feel that it needs to be a bit more well-developed, but what we'll do is look at some more practical examples so we can better understand how to apply their principles, okay? So if we really want to understand how to apply the Microsoft AI principles, they've created this nice little tool via a free web app for practical scenarios. So they have these cards. You can read through these cards. They're color-coded for different scenarios. And there's a website. So let's go take a look at that and see what we can learn, okay? All right, so we're here on the guidelines for human AI interaction, so we can better understand the how to put into practice the Microsoft AI principles. They have 18 cards, and let's work our way through here and see the examples. The first one on our list: make clear what the system can do. Help the users understand what the AI system is capable of doing. So here, PowerPoint Quick Start builds an online outline to help you get started researching a subject. It displays suggested topics that help you understand the feature's capability. Then we have the Bing app shows examples of types of things you can search for. Apple Watch displays all metrics it tracks and explains how. Going on the second card, we have make clear how well the system can do what it can do. So here we have Office new companion experience, ideas dock alongside your work, and offers one-click assistance with grammar, design, data insights, richer images, and more. The unassuming term ideas coupled with label previews help set expectations and presented suggestions. The recommender in Apple Music uses language such as "we will think you'll like" to communicate uncertainty. The help page for Outlook webmail explains the filtering into focused and other, and will start working right away, but will get better with use, making clear the mistakes will happen, and you teach the product and set overrides. Onto our red cards here. We have time services based on context, time when to act or interrupt based on the user's current task and environment. When it's time to leave for appointments, Outlook sends a time to leave notification with directions for both driving and public transit, taking into account current location, event location, real-time traffic information. And then we have, after using Apple Maps routing, it remembers when you're parked your car, when you open the app. After a little while, it suggests routing to the location of the parked car. All these Apple examples make me think that Microsoft has some kind of partnership with Apple. I guess Microsoft or Bill Gates did own Apple shares, so maybe they're closer than we think. Show contextually relevant information, time when to act or interrupt based on user's current task and environment. Powered by machine learning, acronyms in Word helps you understand shorthand employed in your own work environment relative to current open document. On Walmart.com, when the user is looking at a product such as gaming console, it recommends accessories and games that it would go with it. When a user searches for movies, Google shows results including show times near the user's location for the current data. Onto our fifth card here. Match-based, we didn't miss this one, right? Yeah, we did. Okay, so we're on the fifth one here. Match relevant social norms. Ensure experience is delivered in a way the users would expect given the social cultural context. When editor identifies ways to improve writing style, presents optionals politely, consider using. That's the Canadian way, being polite. Google Photos is able to recognize pets and uses the wording important cats and dogs, recognizing that for many, pets are an important part of one's family. And you know what? When I started renting my new house, I said, is there a problem with dogs? And my landlord said, well, of course, pets are part of the family. And that was something I like to hear. Cortana uses semi-formal tone, apologizing when unable to find a contact, which is polite and socially appropriate. I like that. Okay, mitigate social biases. Ensure AI system languages and behaviors do not reinforce undesirable, unfair stereotypes and biases. My Analytics summarizes how you spend your time at work, then suggests ways to work smarter. One way is to mitigate biases by using gender-neutral icons to represent important people. Sounds good to me. A Bing search for CEO or doctor shows images of diverse people in terms of gender and ethnicity. Sounds good to me. The predictive keyboard for Android suggests both genders when typing a pronoun starting with the letter H. We're on to our yellow cards. So support efficient invocation. So make it easy to invoke or request AI system services when needed. So Flashfill is a helpful time saver in Excel that can be easily invoked with on-canvas interactions and that keep you in flow. On Amazon.com, oh, hey, there, got Amazon. In addition to the system giving recommendations as you browse, you can manually invoke additional recommendations from the recommender for your menu. Design ideas in Microsoft PowerPoint can be invoked with the press of a button if needed. I cannot stand it when that pops up. I always have to tell it to leave me alone. Okay, support efficient dismissal. Oh, support efficient dismissal. Okay. Make it easy to dismiss or ignore undesired AI system services. Okay, this sounds good to me. Microsoft Forms allows you to create custom surveys, quizzes, polls, questionnaires, and forms. Some questions trigger suggested options positioned beneath the relevant question. The suggestion can be easily ignored and dismissed. Instagram allows the user to easily hide or report ads that have been suggested by AI by tapping the ellipses at the top of the right of the ad. Siri can be easily dismissed by saying, never mind. I'm always telling my Alexa, never mind. Support efficient correction. Make it easy to edit, refine, or recover the AI system when the AI system is wrong. So alt text automatically generates alt text for photographs by using intelligent services in the cloud. Descriptions can be easily modified by clicking the alt text button in the ribbon. Once you set a reminder with Siri, the UI displays a tap to edit link. When Bing automatically corrects spelling errors in search queries, it provides the option to revert to the query as originally typed with one click. On to card number 10. Scope services when in doubt. So engage in disambiguation or gracefully degrade the AI system service when uncertain about a user's goal. So when auto-replacement word is uncertain of a correction, it engages in a disambiguation by displaying multiple options you can select from. Siri will let you know it has trouble hearing if you don't respond or talk or you speak too softly. Bing Maps will provide multiple routing options when unable to recommend best one. We're on to card number 11. Make clear why the system did what it did. Enable users to access an explanation of why the AI system behaved as it did. Office Online recommends documents based on history and activity. Descriptive text above each document makes it clear why the recommendation is shown. Product recommendations on Amazon.com include why recommended link that shows that what products in the user's shopping history informs the recommendations. Facebook enables you to access an explanation about why you are seeing each ad in the news feed. On to our green cards. So remember recent interactions. So maintain short-term memory and allow the user to make efficient references to that memory. When attaching a file, Outlook offers a list of recent files, including recently copied file links. Outlook also remembers people you have interacted with recently and displays them when addressing a new email. Bing Search remembers some recent queries, and search can be continued conversationally. How old is he after a search for Keanu Reeves? Siri carries over the context from one interaction to the next. A text message is created from the person you told Siri to message to. On to card number 13, lucky number 13. Learn from user behavior. Personalize the user experience by learning from their actions over time. Tap on a search bar in Office applications and search lists the top 3 commands on your screen that you're most likely to need to personalize. The technology called Zero Query doesn't even need to type in the search bar to provide a personalized predictive answer. Amazon.com gives personalized product recommendations based on previous purchases. Onto card 14. Update and adapt cautiously. Limit disruptive changes when adapting the AI system's behaviors. So PowerPoint Designer improves slides for Office 365 subscribers by automatically generating design ideas to choose from. Designer has integrated new capabilities such as smart graphics, icon suggestions, and an existing user experience, ensuring the updates are not disruptive. Office Tell Me feature shows dynamically recommended items and a designated try area to minimize disruptive changes. Onto card number 15. Encourage granular feedback. Enable the users to provide feedback indicating their preferences during regular interactions with the AI system. So Ideas in Excel empowers you to understand your data through high-level visual summaries, trends, and patterns. It encourages feedback on each suggestion by asking, is this helpful? Not only does Instagram provide the option to hide specific ads, but it also solicits feedback to understand why the ad is not relevant. In Apple's music app, love-dislike buttons are prominent, easily accessible. Number 16, convey the consequences of user actions. Immediately update or convey how user actions will impact future behaviors of the AI system. You can get stock and geographic data types in Excel. It is easy as typing text into a cell and converting it to stock data type or geography data type. When you perform the conversion action, an icon immediately appears in the converted cells. Upon tapping the like-dislike button for each recommendation in Apple Music, a pop-up informs the user that they'll receive more or fewer similar recommendations. Onto card number 17. We're almost near the end. Provide global controls. Allow the user to globally customize the AI system monitors and how it behaves. So Editor expands on spelling and grammar checking capabilities of Word to include more advanced proofing and editing designed to ensure document is readable. Editor can flag a range of critique types and allow to customize. The thing is that in Word, it's so awful at spell checking. I don't understand. Like, it's been years and the spell checking never gets better. So they got to employ better spell checking AI, I think. Bing Search provides settings that impact the types of results the engine will return. For example, safe search. Then we have Google Photos, allows users to turn location history on and off for future photos. It's kind of funny seeing like Bing in there about like using AI, because at one point it's almost pretty certain that Bing was copying just Google search indexes to learn how to index. I don't know. That's Microsoft for you. We're on to card 18. Notify users about changes. Inform the user when AI system adds or updates its capabilities. The What's New dialog in Office informs you about changes by giving an overview of the latest features and updates, including updates to AI features. In Outlook Web, the Help tab includes a What's New section that covers updates. So there we go. We made it to the end of the list. I hope that was a fun listen for you. And there, I hope that we could kind of match up the responsible AI. I kind of wish what they would have done is actually mapped it out here and said we're matched, but I guess it's kind of an isolate service that kind of ties in. So I guess there we go. Okay. Hey, this is Andrew Brown from ExamPro, and we are looking at Azure Cognitive Services, and this is a comprehensive family of AI services and cognitive APIs to help you build intelligent apps. So create customizable pre-trained models built with breakthrough AI researches. I put that in quotations. I'm kind of throwing some shade at Microsoft or Azure just because it's their marketing material, right? Deploy cognitive services anywhere from cloud to the edge with containers. Get started quickly. No machine learning expertise required, but I think it helps to have a bit of background knowledge. Develop with strict ethical standards. Microsoft loves talking about their responsible AI stuff, empowering responsible use with industry-leading tools and guidelines. So let's do a quick breakdown of the types of services in this family. So for decision, we have Anomaly Detector, identify potential problems early on. Content Moderator, detect potentially offensive or unwanted content. Personalizer, create rich personalized experiences for every user. For languages, we have Language Understanding, also known as LUIS. I don't know why I didn't put the initialism there, but don't worry, we'll see it again. Build natural language understanding into apps, bots, and IoT devices. QnA Maker, create a conversational question and answer layer over your data. Text analytics, detect sentiment. So sentiment is like whether customers are happy, sad, glad. Keep phrases and named entities. Translator, detect and translate more than 90 supported languages. For speech, we have speech to text, so transcribe audible speech into readable search text. Text to speech, convert text to lifelike speech for natural interfaces. Speech translation, so integrate real-time speech translation into your apps. Speaker recognition, identify and verify the people speaking based on audio. For vision, we have computer vision, so analyze content in images and videos. Custom vision, so customize image recognition to fit your business needs. Face, detect and identify people and emotions in images. So there you go. So Azure Cognitive Services is an umbrella AI service that enables customers to access multiple AI services with an AI key and API endpoint. So what you do is you go create a new cognitive service, and once you're there, it's going to generate out 2 keys and an endpoint, and that is what you're using generally for authentication with the various AI services programmatically. And that is something that is key to the service that you need to know. So knowledge mining is a discipline in AI that uses a combination of intelligent services to quickly learn from vast amounts of information. So it allows organizations to deeply understand and easily explore information, uncover hidden insights, and find relationships and patterns at scale. So we have ingest, enrich, and explore. These are 3 steps. So for ingest, content from a range of sources using connectors to first and third-party data stores. So we might have structured data such as databases, CSVs. The CSVs would more be semi-structured, but we're not going to get into that level of detail. Unstructured data, so PDFs, videos, images, and audio. For enrich, the content with AI capabilities that let you extract information, find patterns, and deepen understanding. So cognitive services like vision, language, speech, decision, and search. And explore the newly indexed data via search bots, existing businesses, applications, and data visualizations. Enrich structured data, customer relationship management, RAP systems, Power BI. This whole knowledge mining thing is a thing, but like I believe that the whole model around this is so that Azure shows you how you can use the cognitive services to solve things without having to invent new solutions. So let's look at a bunch of use cases that Azure has and see where we can find some useful use. So the first one here is for content research. So when organizations task employees to review and research of technical data, it can be tedious to read page after page of dense text. Knowledge mining helps employees quickly review these dense materials. So you have a document, and in the enrichment step, you could be doing printed text recognition, key phrase extraction, sharpen skills, technical keyword sanitation, format definition miner, large-scale vocabulary matcher. You put it through a search service, and now you have search reference library, so it makes things a lot easier to work with. Now we have audit risk compliance management. So developers could use knowledge mining to help attorneys quickly identify entities of importance from discovery documents and flag important ideas across documents. So we have documents, so clause extraction, clause classification, GDPR risk, named identity extraction, key phrase extraction, language detection, automate translation. Then you put it back into a search index, and now you can use it on a management platform or a Word plugin. And so we have business process management in industries where bidding competition is fierce, or when the diagnosis of a problem must be quick or in near real time. Companies use knowledge mining to avoid costly mistakes. So the client drilling and completion reports, document processor, AI services and custom models, Q for human validation, intelligent automation. You send it to a backend system or a data lake, and then you do your analytics dashboard. Then we have customer support and feedback analysis. So for many companies, customer support is costly and inefficient. Knowledge mining can help customer support teams quickly find the right answers for a customer inquiry or assess customer sentiment at scale. So you have your source data, you do your document cracking, use cognitive skills, so pre-trained services are custom. You have enriched documents. From here, you're going to do your projections and have a knowledge store. You're going to have a search index, and then do your analytics, something like Power BI. We have digital assessment management. I know there's a lot of these, but it really helps you understand how cognitive services are going to be useful. Given the amount of unstructured data created daily, many companies are struggling to make use of or find information within their files. Knowledge mining through a search index makes it easy for end customers and employees to locate what they're looking for faster. So you ingest like art metadata and the actual images themselves. For the top layer, we're doing GeoPoint extractor, biographical enricher. Then down below, we're tagging, we're custom object detector, similar image tagger. We put it in a search index. They love those search indexes. And now you have an art explorer. We have contract management. This is the last one here. Many companies create products for multiple sectors, hence the business opportunities with different vendors and buyers increase exponentially. Knowledge mining can help organizations to scour thousands of pages of sources to create accurate bids. So here we have RFP documents. This will actually probably come back later in the original set, but we will we'll do risk extraction, print text recognition, key phrase extraction, organizational extraction, engineering standards. We'll create a search index and put it here. This will bring back data. Also, metadata extraction will come back here. And then this is just like a continuous pipeline, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at face service. And Azure Face Service provides an AI algorithm that can detect, recognize, and analyze human faces and images, such as a face in an image, face with specific attributes, face landmarks, similar faces, and the same face as a specific identity across a gallery of images. So here's an example of an image that I ran that we'll do in the follow along. And what it's done is it's drawn a bounding box around the image. And there's this ID, and this is a unique identifier string for each detected face in an image, and these can be unique across the gallery, which is really useful as well. Another cool thing you can do is face landmarks. So the idea is that you have a face, and it can identify very particular components of it, and up to 27 predefined landmarks is what is provided with this face service. Another interesting thing is face attributes. So you can check whether they're wearing accessories. So think like earrings or lip rings, determine its age, the blurriness of the image, what kind of emotion is being experienced, the exposure of the image, you know, the contrast, facial hair, gender, glasses, your hair in general, the head pose. There's a lot of information around that. Makeup, which seems to be limited. Like when we ran it here in the lab, all we got back was eye makeup and lip makeup, but hey, we get some information, whether they're wearing a mask, noise, so whether there's artifacts, like visual artifacts, or occlusion, so whether an object is blocking the parts of the face, and then they simply have a Boolean value for whether the person's smiling or not, which I assume is a very common component. So that's pretty much all we really need to know about the face service, and there you go. Hey, this is Andrew Brown from ExamPro, and we're looking at the speech and translate service. So Azure's translate service is a translation service, as the name implies, and it can translate 90 languages and dialects. And I was even surprised to find out that it can translate into Klingon, and it uses neural machine translation, NMT, replacing its legacy statistical machine translation, SMT. So what my guess here is that statistical, meaning that it used classical machine learning back in 2010, and then they decided to switch it over to neural networks, which of course would be a lot more accurate. Azure's Translate service can support a custom translator, so it allows you to extend the service for translation based on your business domain use cases. So if you use a lot of technical words and things like that, then you can fine tune that or particular phrases. Then there's the other service, Azure Speech Service, and this is a speech synthesis service. So what it can do is speech to text, text to speech, and speech translation. So it's synthesizing, creating new voices, okay? So we have speech to text, so real-time speech to text, batch batching, multi-device conversation, conversation transcription, and you can create custom speech models. Then you have text-to-speech. So this utilizes a speech synthesis markup language, so it's just a way of formatting it, and it can create custom voices. Then you have the voice assistant, so integrates with the bot framework SDK and speech recognition, so speaker verification and identification. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at text analytics, and this is a service for NLP, so natural language processing, for text mining and text analysis. So text analytics can perform sentiment analysis, so find out what people think about your brand or topic. So features provide sentiment labels such as negative, neutral, positive. Then you have opinion mining, which is an aspect-based sentiment analysis. It's for granular information about the opinions related to aspects. Then you have key phrase extraction, so quickly identify the main concepts in text. You have language detection, so detect the language of an inputted text that it's written in. And you have name entity recognition, so NER, so identify and categorize entities in your text as people, places, objects, and quantities. And subset of NER is personally identifiable information, so PIIs. Let's just look at a few of these more in detail. Some of them are very obvious, but some of these would help to have an example. So the first we're looking at is key phrase extraction. So quickly identify the main concepts in text. So key phrase extraction works best when you give it bigger amounts of text to work on. This is the opposite of sentiment analysis, which performs better on smaller amounts of text. So document sizes can be 5,000 or fewer characters per document. And you can have up to 1,000 items per collection. So imagine you have a movie review with a lot of text in here and you want to extract out the key phrases. So here it identified board, ship, enterprise, surface, travels, things like that. Then you have named entity recognition. So this detects words and phrases mentioned in unstructured data that can be associated with one or more semantic types. And so here's an example. I think this is medicine based. And so the idea is that it's identifying these words or phrases, and then it's applying a semantic type. So it's saying like this is like diagnosis, this is a medication class, and stuff like that. Semantic type could be more broad, so there's location, event, but location twice here, person, diagnosis, age, and there is a predefined set, I believe, that is in Azure that you should expect, but they have a generic one, and then there's one that's for health. We're looking at sentiment analysis. This graphic makes it make a lot more sense when we're splitting between sentiment and opinion mining. But the idea here is that sentiment analysis will apply labels and confidence scores to text at the sentence and document level. And so labels can include negative, positive, mixed, or neutral, and it will have a confidence score ranging from 0 to 1. And so over here, we have a sentiment analysis of this line here, and it's saying that this was a negative sentiment. But look, there's something that's positive, and there's something that's negative. So was it really negative? And that's where opinion mining gets really useful, because it has more granular data, where we have a subject and we have an opinion, right? And so here we can see the room was great, but the staff was unfriendly and negative. So we have a bit of a split there, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at optical character recognition, also known as OCR, and this is the process of extracting printed or handwritten text into a digital and editable format. So OCR can be applied to photos of street signs, products, documents, invoices, bills, financial reports, articles, and more. And so here's an example of us extracting out nutritional data or nutritional facts off the back of a food product. So Azure has two different kinds of APIs that can perform OCR. They have the OCR API and the Read API. So the OCR API uses an older recognition model. It supports only images. It executes synchronously, returning immediately when it detects text. It's suited for less text. It supports more languages. It's easier to implement. And on the other side, we have the Read API. So this is an updated recognition model, supports images and PDFs, executes asynchronously, parallelizes tasks per line for faster results, suited for lots of text, supports fewer languages, and it's a bit more difficult to implement. And so when we want to use this service, we're going to be using Computer Vision SDK, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look here at Form Recognizer Service. This is a specialized OCR service that translates printed text into digital and editable content. It preserves the structure and relationships of the form-like data. That's what makes it so special. So Form Recognizer is used to automate data entry in your applications and enrich your document search capabilities. It can identify key value pairs, selection marks, table structures. It can produce output structures such as original file relationships, bounding boxes, confidence score, and Form Recognizer is composed of a custom document processing models, pre-built models for invoices, receipts, IDs, business cards, the model layouts. Let's talk about the layout here. So extract text, selection marks, table structures, along with bounding box coordinates from documents. Form Recognizer can extract text, selection marks, and table structures, the row and column numbers associated with the text, using high-definition optical character enhancement models. That is totally useless, that text. Hey, this is Andrew Brown from ExamPro, and we are looking at Form Recognizer Service, and this is a specialized service for OCR that translates printed text into digital editable content, but the magic here is that it preserves the structure and relationship of form-like data. So there's an invoice, you see those magenta lines, it's saying, I identify that form-like data. So Form Recognizer is used to automate data entry in your applications and enrich your document search capabilities, and it can identify key value pairs, selection marks, table structures, and it can output structures such as original file relationships, bounding boxes, confidence scores. It's composed of a custom document processing model, pre-built models for invoices, receipts, IDs, and business cards. It's based on this layout model, and there you go. So let's touch upon custom models. So custom models allow you to extract text, key value pairs, selection marks, and tabular data from your forms. These models are trained with your data, so they're tailored to your forms. You only need 5 sample input forms to start. A trained document processing model can output structured data that includes the relationship in the original form document. After you train the model, you can test and retrain it, and eventually use it reliably extract data from more forms according to your needs. You have 2 learning options. You have unsupervised learnings to understand the layout and relationships between fields, entries, and your forms, and you have supervised learning to extract values of interest using the labeled form. So we've covered unsupervised and supervised learning, so you're going to be very familiar with these two, okay? So Form Recognizer Service has many pre-built models that are easy to get started with. And so let's go look at them and see what kind of fields it extracts out by default. So the first is receipts. So sales receipts from Australia, Canada, Great Britain, India, and United States will work great here. And the fields it will extract out is receipt type, merchant name, merchant phone number, merchant address, transaction date, transaction time, total, subtotal, tax, tip, items, name, quantity, price, total price. If there's information that is on a receipt that you're not getting out of these fields, then that's where you make your own custom model, right? For business cards, it's only available for English business cards, but we can extract out contact names, first name, last name, company names, departments, job titles, emails, websites, addresses, mobile phones, faxes, work phones, and other phone numbers. Not sure how many people are using business cards these days, but hey, they have it as an option. For invoices, extract data from invoices in various formats and return structured data. So we have customer name, customer ID, purchase order, invoice ID, invoice date, due date, vendor name, vendor address receipt, customer address receipt, billing address receipt, shipping address, subtotal, total tax, invoice total, amount due, service address, remittance address, service start date and end date, previous unpaid balance. And then they even have one for line items. So items, amount, description, quantity, unit price, product code, unit, date, tax. And then for IDs, which could be worldwide passports, US driver license, things like that, you would have fields such as country, region, date of birth, date of expiration, document name, first name, last name, nationality, sex, machine readable zone. I'm not sure what that is. Document type and address and region. And there is some additional features with some of these models. We didn't really cover them. It's not that important, but yeah, there we go. Hey, this is Andrew Brown from ExamPro, and we were looking at natural understanding, or Luis or Luis, depends on how you like to say it. And this is a no-code ML service to build natural language into apps, bots, and IoT devices. So quickly create enterprise-ready custom models that continuously improve. So Luis, I'm going to just call it Luis because that's what I prefer, is accessed via its own isolate domain at luis.ai, and it utilizes NLP and NLU. So NLU is the ability to perform or ability to transform a linguistic statement to a representation that enables you to understand your users naturally, and it is intended to focus on intention and extraction. Okay, so where the users want, or sorry, what the users want and what the users are talking about. So the Luis application is composed of a schema, and this schema is auto-generated for you when you use the Luis AI web interface. So you definitely aren't going to be writing this by hand, but it just helps to see what's kind of in there. If you do have some programmatic skills, you can make better use of the service than just the web interface. But the schema defines intention, so what the users are asking for. A Luis app always contains a none intent. We'll talk about why that is in a moment. And entities, what parts of the intent is used to determine the answer. Then you also have utterances, so examples of the user input that includes intent and entities to train the ML model to match predictions against the real user input. So an intent requires one or more example utterance for training, and it is recommended to have 15 to 30 example utterances. To explicitly train, to ignore an utterance, you use the none intent. So intent classifies user utterances, and entities extract data from utterances. So hopefully that understands. I always get this stuff mixed up. It always takes me a bit of time to understand. There is more than just these things. There's like features and other things, but for the AI-900, we don't need to go that deep, okay? Just to get to visualizing this to make it a bit easier. So imagine we have this utterance here. These would be the identities. So we have 2 in Toronto. This is the example utterance. And then the idea is that you'd have the intent. And the intent, and if you look at this keyword here, this really helps, where it says classify, that's what it is. It's a classification of this example utterance. And that's how the ML model is going to learn, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at QnA Maker service, and this is a cloud-based NLP service that allows you to create a natural conversational layer over your data. So QnA Maker is hosted on its own isolate domain at QnAMaker.ai. It will help you find the most appropriate answer from any input from your custom knowledge base of information. So you can it's commonly used to build conversation clients, which include social apps, chatbots, speech-enabled desktop applications. QnA Maker doesn't store customer data. All the customer data is stored in the region the customer deploys the dependent services instances within. Okay, so let's look at some of the use cases for this. So when you have static information, you can use QnA Maker in your knowledge base of answers. This knowledge base is custom to your needs, which you've built with documents such as PDF and URLs. When you want to provide the same answer to a repeat question command, when different users submit the same question, the answers is returned. When you want to filter static information based on meta information, so meta tag data is provides additional filtering options relevant to your client application users and information. Common metadata information includes chit-chat, content type, format, content purpose, content freshness. And there's a use case when you want to manage a bot conversation that includes static information. So your knowledge base takes a user's conversational text or command and answers it. If the answer is part of a predetermined conversation flow represented in the knowledge base with multiple turnkey contexts, the bot can easily provide this flow. So QnA Maker imports your content into a knowledge base of questions and answer pairs. And QnA Maker can build your knowledge base from an existing document, manual, or website URL, docx, PDF. I thought this was the coolest thing. So you can just basically have anyone write a docx as long as it has a heading and text. And I think you can even extract out images, and it'll just turn it into the bot. It just saves you so much time. It's crazy. It will use ML to extract the question and answer pairs. The content of the question and answer pairs include all the alternate forms of the question, meta tags used to filter choices during the search, follow-up prompts to continue the search refinement. QnA Maker stores answers text in Markdown. Once your knowledge base is imported, you can fine-tune the imported results by editing the question and answer pairs, as seen here. There is the chat box, so you can converse with your bot through a chat box. I wouldn't say it's particularly a feature of QnA Maker, but I just want you to know that's how you'd interact with it. So when you're using the QnA Maker AI, the Azure Bot Service, the Bot Composer, or via channels, you'll get an embeddable one. You'll see this box where you can start typing in your questions and get back the answers to test it. Here, an example is a multi-turn conversation. So somebody asked a question, a generic question, and that said, hey, are you talking about AWS or Azure, which is kind of like a follow-up prompt. And we'll talk about multi-turn here in a second, but that's something I want you to know about, okay? So Chit Chat is a feature in QnA Maker that allows you to easily add pre-populated sets of top chit chats into your knowledge base. The dataset has about 100 scenarios of chit chat in voices of multiple personas. So the idea is like if someone says something random like, how are you doing? What's the weather today? Things that your bot wouldn't necessarily know. It has like canned answers, and it's going to be different based on how you want the response to be, okay? There's a concept of layered ranking. So QnA Maker system is a layered ranking approach. The data is stored in Azure Search, which also serves as the first ranking layer. The top result from Azure Search are then passed through QnA Maker's NLP re-ranking model to produce the final results and confidence score. Touching on multi-turn conversation is a follow-up prompt and context to manage the multiple turns known as multi-turn for your bot from one question to another. When a question can't be answered in a single turn, that is when you're using multi-turn conversation. So QnA Maker provides multi-turn prompts and active learning to help you improve your questions based on key and answer pairs. And it gives you the opportunity to connect questions and answer pairs. The connection allows the client application to provide a top answer and provide more questions to refine the search for a final answer. After the knowledge base receives questions from users at the published endpoint, QnA Maker applies active learning to these real-world questions to suggest changes to your knowledge base to improve the quality. All right? Hey, this is Andrew Brown from ExamPro, and we are looking at Azure Bot Service. So the Azure Bot Service is an intelligent serverless bot service that scales on demand, used for creating, publishing, and managing bots. So you can register and publish a variety of bots from the Azure portal. So here there's a bunch of ones I've never heard of, probably with third-party providers partnered with Azure. And then there's the ones that we would know, like the Azure Health Bot, the Azure Bot, or the web app bot, which is more of a generic one. So Azure Bot Service can integrate your bot with other Azure, Microsoft, or third-party services via channels. So you can have a direct line, Alexa, Office 365, Facebook, Keek, Line, Microsoft Teams, Skype, Twilio, and more. All right. And two things that are commonly associated with the Azure Bot Service is the Bot Framework and Bot Composer. In fact, it was really hard just to make this slide here because they just weren't very descriptive on it because I wanted to push these other two things here. But let's talk about the Bot Framework SDK. So the Bot Framework SDK, which is now version 4, is an open source SDK that enables developers to model and build sophisticated conversations. The Bot Framework, along with the Azure Bot Service, provides an end-to-end workflow so we can design, build, test, publish, connect, and evaluate our bots. Okay, with this framework, developers can create bots that use speech, understand natural language, handle questions, answers, and more. The bot framework includes a modular extensible SDK for building bots, as well as tools, templates, and related AI services. Then you have Bot Framework Composer. And this is built on top of the Bot Framework SDK. It's an open source IDE for developers to author, test, provision, and manage conversational experiences. You can download it. It's an app on Windows OS X and Linux. It's probably built using web technology. And so here is the actual app there. And so you can see there's kind of a bit of a flow and things you can do in there. So you can either use C or Node to build your bot. You can deploy the bot to the Azure Web Apps or Azure Functions. You have templates to build QnA Maker bot, enterprise or personal assistant bot, language bot, calendar or people bot. You can test and debug via the Bot Framework emulator, and it has a built-in package manager. There's a lot more to these things, but again, at the AI-900, this is all we need to know. But yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Azure Machine Learning Service. I want you to know there's a classic version of the service. It's still accessible in the portal. This is not an exam. We are going to 100% avoid it. It has severe limitations. We cannot transfer anything over from the classic to the new one. So the one we're going to focus on is the Azure Machine Learning Service. you do create studios within it. So you'll hear me say Azure Machine Learning Studio, and I'm referring to the new one. A service that simplifies running AI ML related workloads, allowing you to build flexible automated ML pipelines, use Python or R, run deep learning workloads such as TensorFlow. We can make Juypter Notebooks in here, so build and document your machine learning models as you build them, share and collaborate. Azure Machine Learning SDK for Python, so an SDK designed specifically to interact with the Azure Machine Learning services. It does ML ops, machine learning operations, so end-to-end automation of ML model pipelines, CI/CD, training, inference. Azure Machine Learning Designer, so this is a drag and drop interface to visually build, test, deploy machine learning models, or technically pipelines, I guess, as a data labeling service. So assemble a team of humans to label your training data. Responsible machine learning, so model fairness through disparity metrics and mitigate unfairness. At the time of this service, this is not very good, but it's supposed to tie in with the responsible AI that Microsoft is always promoting, okay? So once we launch our own studio within Azure Machine Learning Service, you're going to get this nice big bar or navigation left-hand side. It shows you there's a lot of stuff that's in here. So let's just break it down on what all these things are. So for authoring, we got notebooks. These are Juypter Notebooks and IDE to write Python code to build ML models. They kind of have their own preview, which I don't really like, but there is a way to bridge it over to Juypter Notebooks or to Visual Studio Code. We have AutoML, completely automated process to build and train ML models. So they're limited to only 3 types of models, but still, that's great. We have the designer, so Visual Drag and Drop Designer to construct end-to-end ML pipelines. For assets, we have datasets, so data that you can upload, which will be used for training, experiments. When you run a training job, they are detailed here. Pipelines, ML workflows you have built or have used in the designer. Models, so a model registry containing trained models that can be deployed. Endpoints, so when you deploy a model, it's hosted on accessible endpoint. So you're going to be able to access it via a REST API or maybe the SDK. For manage, we got compute, the underlying computing instances used for notebooks, training, and inference. Environments, a reproducible Python environment for machine learning experiments. Data stores, a data repository where your data resides. Data labeling, so you have a human with ML-assisted labeling to label your data for supervised learning. Link services, external service you can connect to the workspace such as Azure Synapse Analytics. Let's take a look at the types of compute that is available in our Azure Machine Learning Studio. We got 4 categories. We have compute instances, development workstations that data scientists can use to work with data and models, compute clusters, so scalable clusters of VMs for on-demand processing and experimentation code, deployment targets for predictive services that use your trained models, and attached compute links to existing Azure compute resources such as Azure VMs, and Azure Databricks clusters. Now, what's interesting here is like with this compute, you can see that you can open it in Jupyter Labs, Jupyter, VS Code, R Studio, and Terminal. But you can work with your compute instances, your development workstations directly in the studio, which that's the way I do it. What's interesting is for inference, that's when you want to make a prediction, you use Azure Kubernetes Service or Azure Container Instance. And I didn't see it show up under here, so I'm kind of confused whether that's where it appears. Maybe we'll discover as we do the follow-alongs that they do appear here, but I'm not sure about that one. But yeah, those are the 4 there, okay? So within Azure Machine Learning Studio, we can do some data labeling. So we create data labeling jobs to prepare your ground truth for supervised learning. We have 2 options, human in the loop labeling. You have a team of humans that will apply labeling. These are humans you grant access to labeling. Machine learning assisted data labeling, you will use ML to perform labeling. So you can export the labeled data for machine learning experimentation at any time. Your users often export multiple times and train different models rather than wait for all the images to be labeled. Images labels can be exported in COCO format. That's why we talked about COCO a lot earlier in our dataset section. Azure Machine Learning Dataset, and this is the dataset format that makes it easy to use for training in Azure Machine Learning. So generally you want to use that format. The idea is you would choose a labeling task type, and that way you would have this UI and then people would go in and just click buttons and do the labeling, okay? So Azure ML Data Store securely connects you to storage services on Azure without putting your authentication credentials and the integrity of your original data source at risk. So here is the example of data stores that are available to us in the studio. And let's just go quickly through them. So we have Azure Blob Storage. This is data that is stored as objects distributed across many machines. Azure File Share, a mountable file share via SMB and NFS protocols. Azure Data Lake Storage Gen 2. This is blob storage designed for vast amounts of big data analytics. Azure SQL. This is a fully managed MS SQL relational database. Azure Postgres database. This is an open source relational database, often considered an object-related database, preferred by developers. Azure MySQL, another open source relational database, the most popular one, and considered a pure relational database. Okay. So Azure ML Datasets makes it easy to register your datasets for use with your ML workload. So what you do is you'd add a dataset and you get a bunch of metadata associated with it. And you can also upload like the dataset again to have multiple versions. So you'll have a current version and a latest version. It's very easy to get started working with them because they'll have some sample code that's for the Azure ML SDK to import that into your Juypter Notebooks. For datasets, you can generate out profiles that will give you summary statistics, distribution of data, and more. You will have to use a compute instance to generate that data. So you'd press the generate profile and you'd have that stored. I think it's in blob storage. There are open datasets. These are publicly hosted datasets that are commonly used for learning how to build ML models. So if you go to open datasets, you just choose one. And so this is a curated list of open datasets that you can quickly add to your data store. Great for learning how to use AutoML or Azure Machine Learning Designer or any kind of ML workload if you're new to it. That's why we covered MNIST and Cocoa earlier, just because those are some common data sets there. But there you go. Taking a look here at Azure ML Experiments, this is a logical grouping of Azure runs, and runs is the act of running an ML task on a virtual machine or container. So here's a list of them, and it can run various types of ML tasks. So scripts could be pre-processing, AutoML, a training pipeline, but what it's not going to include is inference. And what I mean is once you've deployed your model or pipeline and you make predictions via a request, it's just not going to show up under here. Okay. Okay, so we have Azure ML Pipelines, which is an executable workflow of a complete machine learning task, not to be confused with Azure Pipelines, which is part of Azure DevOps, or Data Factory, which has its own pipelines. It's a totally separate thing here. So subtasks are encapsulated as a series of steps within the pipeline. Independent steps allow multiple data scientists to work on the same pipeline at the same time without overtaxing compute resources. Separate steps also make it easy to use different compute type sizes for each step. When you rerun a pipeline, the run jumps to the steps that need to be rerun, such as the updated training script. Steps do not need to be rerun, and they will be skipped. After a pipeline has been published, you can configure a REST endpoint, which allows you to rerun the pipeline from any platform or stack. There's two ways to build pipelines. You can use the Azure ML Designer or pragmatically using Azure Machine Learning Python SDK. So here is an example of some code. Just make a note here. I mean, it's not that important, but no, it's just you create steps, okay? And then you assemble all the steps into a pipeline here, all right? So Azure Machine Learning Designer lets you quickly build Azure ML pipelines without having to write any code. So here is what it looks like. And over there, you can see our pipeline is quite visual. And on the left-hand side, you have a bunch of assets you can drag out that are pre-built there. So it's a really fast way for building a pipeline. So you do have to have a good understanding of ML pipelines end-to-end to make good use of it. Once you've trained your pipeline, you can create an inference pipeline. So you drop down and you'd say whether you want it to be real or batch. And you can toggle between them later. So, I mean, there's a lot to this service, but for the AI-900, we don't have to go diving too deep, okay? So Azure ML Models, or the Model Registry, allows you to create, manage, and track your registered models as incremental versions under the same name. So each time you register a model with the same name as an existing one, the registry assures that it's a new version. Additionally, you can provide metadata tags and use tags when you search for models. So yeah, it's just a really easy way to share and deploy or download your models, okay? Azure ML endpoints allow you to deploy machine learning models as a web service. So the workflow for deploying models is register the model, prepare an entry script, prepare an inference configuration, deploy the model locally to ensure everything works, choose a compute target, redeploy the model to the cloud, test the resulting web service. So we have two options here, real-time endpoints. So an endpoint that provides remote access to invoke the ML model service running on either Azure Kubernetes Service, AKS, or Azure Container Instance, ACI. Then we have pipeline endpoints, so an endpoint that provides remote access to invoke an ML pipeline. You can parameterize the pipeline endpoint for managed repeatability in batch scoring and retraining scenarios. And so you can deploy a model to an endpoint. It will either be deployed to AKS or ACI, as we said earlier. And the thing is that when you do that, just understand that that's going to be shown under the AKS or ACI within the Azure portal. It's not consolidated under the Azure Machine Learning Studio. When you've deployed a real-time endpoint, you can test the endpoint by sending either a single request or a batch request. So they have a nice form here where it's single, or it's like here, it's a CSV that you can send. So there you go. So Azure has a built-in Jupyter-like notebook editor, so you can build and train your ML models. And so here is an example of it. I personally don't like it too much, but that's okay because we have some other options to make it easier. But what you do is you choose your compute instance to run the notebook. You'll choose your kernel, which is a preloaded programming language and programming libraries for different use cases. But that's a Jupyter kernel concept there. So you can open the notebook in a more familiar ID, such as VS Code, Jupyter Notebook Classic, or Jupyter Lab. So you go there, drop it down, choose it, and open it up, and now you're in a more familiar territory. The VS Code one is exactly the same experience as the one in Azure or Azure ML Studio. I personally don't like it. I think most people are going to be using the notebooks, but it's great that they have all those options. So Azure Automated Machine Learning, also known as AutoML, automates the process of creating an ML model. So with Azure AutoML, you supply a data set, choose a task type, and then AutoML will train and tune your model. So here are our task types. Let's quickly go through them. So we have classification, when you need to make a prediction based on several classes. So binary classification, multi-class classification, regression, when you need to predict a continuous number value, and then time series forecasting, when you need to predict the value based on time. So just look at them a little bit more in detail. So classification is a type of supervised learning in which the model learns using training data and apply those learnings to new data. So here is an example, or this is just the option here. And so the goal of classification is to predict which categories new data will fall into based on learning from its training data. So binary classification is a record is labeled out of two possible labels. So maybe it's true or false, 0 or 1. It's just two values. Multi-class classification is a record is labeled out of a range of labels. And so it could be like happy, sad, mad, or rad. And just, you know, I can see there's a spelling mistake there, but yeah, there should be an F. So let's just correct that. There we go. You can also apply deep learning. And so if you turn deep learning on, you probably will want to use a GPU compute instance just because, or compute cluster, because deep learning really prefers GPUs, okay? Looking at regression, it's also a type of supervised learning where the model learns using training data and applies those learnings to new data, but it's a bit different where the goal of regression is to predict a variable in the future. Then you have time series forecasting, and this sounds a lot like regression because it is. So forecast revenue, inventory sales, or customer demand, an automated time series experiment that is treated as a multivariate regression problem. Past time series values are pivoted to become additional dimensions for the regressor together with other predictors. And unlike classical time series methods, has an advantage of naturally incorporating multiple contextual variables and their relationship to one another during training. So use cases here, or advanced configurations, I should say, holiday detection and featurization, time series deep learning neural networks. So you got ARIMA, Profit, Forecast TCN, many model supports through grouping, rolling origin cross-validation, configurable labs, rolling window aggregate features. So there you go. So within AutoML, we have data guardrails, and these are run by AutoML when automatic featurization is enabled. It's a sequence of checks to ensure high-quality input data is being used to train the model. So just to show you some information here. So the idea is it could apply validation split handling. So the input data has been split for validation to improve the performance. Then you have missing feature value imputation. So no features missing values were detected in training data. High cardinality feature detection. Your inputs were analyzed and no high cardinality features were detected. High cardinality means like if you have too many dimensions, it becomes very dense or hard to process the data. So that's something good to check against. Let's talk about AutoML's automatic featurization. So during model training with AutoML, one of the following scaling or normalization techniques will be applied to each model. The first is standard scale wrappers. So standardize features by removing the mean and scaling to unit variance. Min-max scalar, transform features by scaling each feature by the column's minimum maximum. Max ABS scalar, scale each feature by its maximum absolute value. Robust scalar scales features by the quantile range. PCA, linear dimensionality reduction using single value decomposition of the data to project it to lower dimensional space. Dimension reduction is very useful if your data is too complex. Let's say you have data, you have too many labels, like 20, 30, 40 labels for categories to pick out of. You want to reduce the dimensions so that your machine learning model is not overwhelmed. So then you have truncated SVD wrappers. So the transformer performs linear dimensionality reduction by means of truncated singular value decomposition. Contrary to PCA, the estimator does not center the data before computing the singular value decomposition, which means it can work with spicy sparse matrices efficiently. Sparse normalization. Each sample, that is each row of the data matrix, which with at least one zero component, is rescaled independently of other samples so that it is norm. So 1L or 2L2. I can't remember if it's I2 or L. Anyway, I1 and I2. Okay. So the thing is that on the exam, they're probably not going to be asking you these questions, but I just like to get you exposure. But I just want to show you that AutoML is doing all this. This is like pre-processing stuff, you know, like this is stuff that you'd have to do. And so it's just taking care of the stuff for you, okay? So within Azure AutoML, they have a feature called model selection. And this is the task of selecting a statistical model from a set of candidate models. And Azure AutoML will use different or many different ML algorithms that will recommend the best performing candidates. So here is a list, and I want to just point out down below, there's 3 pages, there's 53 models. That's a lot of models. And so you can see that the one it chose as its top candidate was called Voting Ensemble. That's an ensemble algorithm. That's where you take 2 weak ML models, combine them together to make a more stronger one. And notice here, it will show us the results. And this is what we're looking for, which is the primary metric. The highest value should indicate that that's the model we should want to use. You can get an explanation of the model called, that's known as explainability. And now if you're a data scientist, you might be a bit smarter and say, well, I know this one should be better, so I'll use this and tweak it. But you know, if you don't know what you're doing, you just go with the top one, okay? So we just saw that we had a top candidate model, and there could be an explanation to understand as to the effectiveness of this. So this is called MXL, so machine learning explainability. This is the process of explaining, interpreting ML or deep learning models. MLX can help machine learning developers to better understand and interpret models' behavior. So after your top candidate model is selected by Azure AutoML, you can get an explanation of internals of various factors. So model performance, dataset explorer, aggregate feature importance, individual feature importance. So, I mean, yeah, this is aggregate. So what it's looking at, and it's actually cut off here, but it's saying that these are the most important ones that affect how the model's outcome. So I think this is the diabetes data set. So BMI would be one that would be a huge influence there, okay? So the primary metric is a parameter that determines the metric to be used during the model training for optimization. So for classification, we have a few, and regression and time series, we have a few. But you'll have these task types, and underneath you'll choose the additional configuration, and that's where you can override the primary metric. It might just auto-detect it for you, so you don't have to, because it might sample some of your data set to just kind of guess. but you might have to override it yourself. Just going through some scenarios, and we'll break it down into two categories. So here we have suited for larger data sets that are well balanced. Well balanced means that your data set is evenly distributed. So if you have classifications for A and B, let's say you have 100 and 100, they're well balanced, right? You don't have one data set a subset of your data set much larger than the other that's labeled. So for accuracy, this is great for image classification, sentiment analysis, churn prediction. For average precision score weighted, it's for sentiment analysis. Norm macro recall, churn prediction. For precision score weighted, uncertain as to what that would be good for, maybe sentiment analysis. Suited for smaller data sets that are inbound, so that's where your data set, you might have 10 records for one and 500 for the other on the label. So you have AUC weighted, fraud detection, image classification, anomaly detection, spam detection. Onto regression scenarios, we'll break it down into ranges. So when you have a very wide range, Spearman correlation works really well. R2 score, this is great for airline delay, salary estimation, bug resolution time. When you're looking at smaller ranges, we're talking about normalized root square mean to error, so price predictions, review tip score predictions. For normalized mean absolute error, it's going to be just another one here. They don't give a description. For time series, it's the same thing. It's just in the context of time series, so forecasting, all right? Another option we can change is the validation type when we're setting up our ML model. So model validation is when we compare the results of our training data set to our test data set. Model validation occurs after we train the model. And so you can just drop it down there and we have some options. So auto, K-fold cross-validation, Monte Carlo cross-validation, train validation split. I'm not going to really get into the details of that. I don't think it'll show up on the AI-900 exam, but I just want you to be aware that you do have those options, okay? Hey, this is Andrew Brown from ExamPro, and we're taking a look here at Custom Vision, and this is a fully managed no-code service to quickly build your own classification and object detection ML models. The service is hosted on its own isolate domain at www.customvision.ai. So the first idea is you upload your images, so bring your own labeled images or Custom Vision to quickly add tags to any unlabeled data images. You use the labeled images to teach Custom Vision the concepts you care about, which is training, and you use a simple REST API that calls to quickly tag images with your new custom computer vision model so you can evaluate, okay? So when we launch Custom Vision, we have to create a project, and with that, we need to choose a project type, and we have classification and object detection. Reviewing classification here, you have the option between multi-label, so when you want to apply many tags to an image. So think of an image that contains both a cat and a dog. You have multi-class, so when you only have one possible tag to apply to an image, so it's either an apple, banana, and an orange, it's not multiples of these things. You have object detection. This is when we want to detect various objects in an image. And you'll also need to choose a domain. A domain is a Microsoft managed data set that is used for training the ML model. There are different domains that are suited for different use cases. So let's go take a look first at image classification domains. So here is the big list, the domains being over here. Okay. And we'll go through these here. So general is optimized for a broad range of image classification tasks. If none of the other specified domains are appropriate, or you're unsure of which domain to choose, select one of the general domains. So A1 is optimized for better accuracy with comparable inference time as general domain, recommended for larger data sets or more difficult user scenarios. This domain requires more training time. Then you have A2, optimized for better accuracy with faster inference times than A1. And general domains, recommended for most data sets. This domain requires less training time than general and A1. You have food, optimized for photographs or dishes as you would see them on a restaurant menu. If you want to classify photographs of individual fruits or vegetables, use food domains. So then we have optimized for recognizable landmarks, both natural and artificial. This domain works best when landmark is clearly visible in the photograph. This domain works even if the landmark is slightly obstructed by people in front of it. Then you have retail, so optimized for images that are found in a shopping cart or shopping website. If you want a high precision classifying between dresses, pants, shirts, use this domain. Compact domains, optimized for the constraints of real-time classification on the edge. Okay. Then we have object detection domains. So this one's a lot shorter, so we'll get through a lot quicker. So optimize for a broad range of object detection tasks. If none of the other domains are appropriate, or you're unsure of which domain, choose the general one. A1, optimize for better accuracy and comparable inference time than the general domain. Recommended for most accurate region locations, larger data sets, or more difficult use case scenarios. The domain requires more training and results are not deterministic. Expect plus minus 1% mean average precision difference with the same training data provided. You have logo, optimized for finding brands, logos, and images, products on shelves, so optimized for detecting and classifying products on the shelf. So there you go. Okay, so let's get some more practical knowledge of the service. So for image classification, you're going to upload multiple images and apply a single or multiple labels to the entire image. So here I have a bunch of images uploaded, and then I have my tags over here. And they could either be multi or singular. For object detection, you apply tags to objects in an image for data labeling, and you hover your cursor over the image. Custom Vision uses ML to show bounding boxes of possible objects that have not yet been labeled. If it does not detect it, you can also just click and drag to draw out whatever square you want. So here's one where I tagged it up quite a bit. You have to have at least 50 images on every tag to train, so just be aware of that when you are tagging your images. When you're training, your model is ready when and you have two options. So you have quick training, this trains quickly, but it will be less accurate. You have advanced training. This increases compute time to improve your results. So for advanced training, basically you just have this thing that you move to the right. With each iteration of training, our ML model will improve the evaluation metrics, so precision and recall. It's going to vary, and we're going to talk about the metrics here in a moment, but the probability threshold value determines when to stop training, when our evaluation metric meets our desired threshold. So these are just additional options where when you're training, you can move this left to right, and these left to right, okay? And then when we get our results back, we're going to get some metrics here. So we have evaluation metrics, so we have precision, being exact and accurate, selects items that are relevant, recall, set sensitivity, or known as true positive rate, how many relevant items returned, average precision. It's important that you remember these because they might ask you that on the exam. So for when we're looking at object detection and we're looking at the evaluation metric outcomes for this one, we have precision, recall, and mean average precision. Once we've deployed our pipeline, it makes sense that we should go ahead and give it a quick test to make sure it's working correctly. So you press the quick test button and you can upload your image and it will tell you. So this one says it's WARF. When you're ready to publish, you just hit the publish button. And then you'll get some prediction URL and information so you can invoke it. One other feature that's kind of useful is the smart labeler. So once you've loaded some training data within, it can now make suggestions, right? So you can't do this right away, but once it has some data, it's like kind of a prediction that is not 100% guaranteed, right? And it just helps you build up your training data set a lot faster. Very useful if you have a very large data set. This is known as ML-assisted labeling, okay? Hey, this is Andrew Brown from ExamPro, and in this section, we'll be covering the newly added section to the AI-900 that focuses on generative AI. Generative AI, including technologies like ChatGPT, is becoming more recognized outside of tech circles. While it may seem magical in its ability to produce human-like content, it's actually based on advanced mathematical techniques from statistics, data science, and machine learning. Understanding these core concepts can help society envision new AI possibilities for the future. First, let's compare the differences between regular AI versus generative AI. AI refers to the development of computer systems that can perform tasks typically requiring human intelligence. These include problem solving, decision making, understanding natural language, recognizing speech and images, and more. The primary goal of traditional AI is to create systems that can interpret, analyze, and respond to human actions or environmental changes efficiently and accurately. It aims to replicate or simulate human intelligence in machines. AI applications are vast and include areas like expert systems, natural language processing, speech recognition, and robotics. AI is used in various industries for tasks such as customer service chatbots, recommendation systems in e-commerce, autonomous vehicles, and medical diagnosis. On the other hand, generative AI is a subset of AI that focuses on creating new content or data that is novel and realistic. It does not just interpret or analyze data, but generates new data itself. It includes generating text, images, music, speech, and other forms of media. It often involves advanced machine learning techniques, particularly deep learning models like generative adversarial networks, variational autoencoders, and transformer models like GPT. Generative AI is used in a range of applications, including creating realistic images and videos, generating human-like text, composing music, creating virtual environments, and even drug discovery. Some examples include tools like GPT for text generation, DALL-E for image creation, and various deep learning models that compose music. So let's quickly summarize the differences of regular AI with generative AI across three features: functionality, data handling, and applications. Regular AI focuses on understanding and decision-making, whereas generative AI is about creating new, original outputs. In terms of data handling, regular AI analyzes and bases decisions on existing data, while generative AI uses the same data to generate new, previously unseen outputs. And for applications, regular AI's scope includes data analysis, automation, natural language processing, and healthcare. In contrast, generative AI leans towards more creative and innovative applications such as content creation, synthetic data generation, deepfakes, and design. The next topic we'll be covering is what is a large language model. A large language model such as GPT works in a way that's similar to a complex, automatic system that recognizes patterns and makes predictions. Training on large datasets. Initially, the model is trained on massive amounts of text data. This data can include books, articles, websites, and other written material. During this training phase, the model learns patterns in language, such as grammar, word usage, sentence structure, and even style and tone. Understanding context, the model's design allows it to consider a wide context. This means it doesn't just focus on single words, but understands them in relation to the words and sentences that come before and after. This context understanding is important for generating coherent and relevant text. Predicting the next word. When you give the model a prompt, which is a starting piece of text, it uses what it has learned to predict the next most likely word. It then adds this word to the prompt and repeats the process, continually predicting the next word based on the extended sequence. Generating text. This process of predicting the next word continues, creating a chain of words that forms a coherent piece of text. The length of this generated text can vary based on specific instructions or limitations set for the model. Refinement with feedback. The model can be further refined and improved over time with feedback. This means it gets better at understanding and generating text as it is exposed to more data and usage. In summary, a large language model works by learning from a vast quantity of text data, understanding the context of language, and using this understanding to predict and generate new text that is coherent and contextually appropriate, which can be further refined with feedback, as shown in the workflow image. Next, let's talk about transformer models. So, a transformer model is a type of machine learning model that's especially good at understanding and generating language. It's built using a structure called the transformer architecture, which is really effective for tasks involving natural language processing, like translating languages or writing text. Transformer model architecture consists of two components, or blocks. First, we have the encoder. This part reads and understands the input text. It's like a smart system that goes through everything it's been taught, which is a lot of text, and picks up on the meanings of words and how they're used in different contexts. Then we have the decoder. So, based on what the encoder has learned, this part generates new pieces of text. It's like a skilled writer that can make up sentences that flow well and make sense. There are different types of transformer models with specific jobs. For example, BERT is good at understanding the language. It's like a librarian who knows where every book is and what's inside them. Google uses it to help its search engine understand what you're looking for. GPT is good at creating text. It's like a skilled author who can write stories, articles, or conversations based on what it has learned. So that's an overview of a transformer model. Next, we'll be talking about the main components of a transformer model. The next component of a transformer model we'll be covering is the tokenization process. Tokenization in a transformer model is like turning a sentence into a puzzle. For example, you have the sentence, "I heard a dog bark loudly at a cat." To help a computer understand it, we chop up the sentence into pieces called tokens. Each piece can be a word or even a part of a word. So, for our sentence, we give each word a number like this. I might be 1, heard might be 2, might be 3, dog might be 4, bark might be 5, loudly might be 6, at might be 7, is already tokenized as 3. Cat might be 8. Now, our sentence becomes a series of numbers. This is like giving each word a special code. The computer uses these codes to learn about the words and how they fit together. If a word repeats, like A, we use its code again instead of making a new one. As the computer reads more text, it keeps turning new words into new tokens with new numbers. If it learns the word meow, it might call it 9, and skateboard could be 10. By doing this with lots and lots of text, the computer builds a big list of these tokens, which it then uses to understand and generate language. It's a bit like creating a dictionary where every word has a unique number. The next component of a transformer model we'll be covering are embeddings. So, to help a computer understand language, we turn words into tokens and then give each token a special numeric code, called an embedding. These embeddings are like a secret code that captures the meaning of the word. As a simple example, suppose the embeddings for our tokens consist of vectors with 3 elements. For example, 4 for dog has the embedding vectors 10, 3, 2. 5 for bark has the vectors 10, 2, 2. 8 for cat, the vectors are 10, 3, 1. 9 for meow, the vectors are 10, 2, 1. And 10 for skateboard has the vectors 3, 3, 1, which is quite different from the rest. Words that have similar meanings or are used in similar ways get codes that look alike. So dog and bark might have similar codes because they are related, but skateboard might be off in a different area because it's not much related to these other words. This way, the computer can figure out which words are similar to each other just by looking at their codes. It's like giving each word a home on a map, and words that are neighbors on this map have related meanings. The image shows a simple example model in which each embedding has only 3 dimensions. Real language models have many more dimensions. Tools such as Word2Vec or the encoding part of a transformer model help AI to figure out where each word dot should go on this big map. Let's go over positional encoding from a transformer model. Positional encoding is a technique used to ensure that a language model, such as GPT, doesn't lose the order of words when processing natural language. This is important because the order in which words appear can change the meaning of a sentence. Let's take the sentence "I heard a dog bark loudly at a cat" from our previous example. Without positional encoding, if we simply tokenize this sentence and convert the tokens into embedding vectors, we might end up with a set of vectors that lose the sequence information. Positional encoding adds a positional vector to each word in order to keep track of the positions of the words. However, by adding positional encoding vectors to each word's embedding, we ensure that each position in the sentence is uniquely identified. The embedding for I would be modified by adding a positional vector corresponding to position 1, labeled I1. The embedding for heard would be altered by a vector for position 2, labeled heard 2. The embedding for it would be updated with a vector for position 3, labeled A3, and reused with the same positional vector for its second occurrence. This process continues for each word token in the sentence, with dog 4, bark 5, loudly 6, at 7, and cat 8 all receiving their unique positional encodings. As a result, the sentence "I heard a dog bark loudly at a cat" is represented not just by a sequence of vectors for its words, but by a sequence of vectors that are influenced by the position of each word in the sentence. This means that even if another sentence had the same words in a different order, its overall representation would be different because the positional encodings would differ, reflecting the different sequence of words. So that's an overview of positional encoding. The next component of a transformer we'll be covering is attention. Attention in AI, especially in transformer models, is a way the model figures out how important each word or token is to the meaning of a sentence, particularly in relation to the other words around it. Let's reuse the sentence "I heard a dog bark loudly at a cat" to explain this better. Self-attention, imagine each word in the sentence shining a flashlight on the other words. The brightness of the light shows how much one word should pay attention to the others when understanding the sentence. For bark, the light might shine brightest on dog because they're closely related. Encoder's role: in the encoder part of a transformer model, attention helps decide how to represent each word as a number or vector. It's not just the word itself, but also its context that matters. For example, bark in the bark of a tree would have a different representation than bark in "I heard a dog bark" because the surrounding words are different. Decoder's role: when generating new text, like completing a sentence, the decoder uses attention to figure out which words it already has are most important for deciding what comes next. If our sentence is "I heard a dog," the model uses attention to know that heard and dog are key to adding the next word, which might be bark. Multi-head attention: this is like having multiple flashlights, each highlighting different aspects of the words. Maybe one flashlight looks at the meaning of the word, another looks at its role in the sentence, like subject or object, and so on. This helps the model get a richer understanding of the text. Building the output, the decoder builds the sentence one word at a time, using attention at each step. It looks at the sentence so far, decides what's important, and then predicts the next word. It's an ongoing process, with each new word influencing the next. So, attention in transformer models is like a guide that helps the AI understand and create language by focusing on the most relevant parts of the text, considering both individual word meanings and their relationships within the sentence. Let's take a look at the attention process. Token embeddings: each word in the sentence is represented as a vector of numbers, or its embedding. Predicting the next token: the goal is to figure out what the next word should be, also represented as a vector. Assigning weights: the attention layer looks at the sentence so far and decides how much influence each word should have on the next one. Calculating attention scores: using these weights, a new vector for the next token is calculated, which includes an attention score. Multi-head attention does this several times, focusing on different aspects of the words. Choosing the most likely word: a neural network takes these vectors with attention scores and picks the word from the vocabulary that most likely comes next. Adding to the sequence: the chosen word is added to the existing sequence, and the process repeats for each new word. So let's use GPT-4 as an example for how this entire process works, explained in a simplified manner. A transformer model like GPT-4 works by taking a text input and producing a well-structured output. During training, it learns from a vast array of text data, understanding how words are typically arranged in sentences. The model knows the correct sequence of words but hides future words to learn how to predict them. When it tries to predict a word, it compares its guess to the actual word, gradually adjusting to reduce errors. In practice, the model uses its training to assign importance to each word in a sequence, helping it guess the next word accurately. The result is that GPT-4 can create sentences that sound like they were written by a human. However, this doesn't mean the model knows things or is intelligent in the human sense. It's simply very good at using its large vocabulary and training to generate realistic text based on word relationships. So that's an overview of attention in a transformer model. Hey, this is Andrew Brown from ExamPro, and in this section, we'll be going over an introduction to Azure OpenAI Service. Azure OpenAI Service is a cloud-based platform designed to deploy and manage advanced language models from OpenAI. This service combines OpenAI's latest language model developments with the robust security and scalability of Azure's cloud infrastructure. Azure OpenAI offers several types of models for different purposes. GPT-4 models: these are the newest in the line of GPT models and can create text and programming code when given a prompt written in natural language. GPT 3.5 models: similar to GPT-4, these models also create text and code from natural language prompts. The GPT 3.5 Turbo version is specially designed for conversations, making it a great choice for chat applications and other interactive AI tasks. Embedding models: these models turn written text into number sequences, which is helpful for analyzing and comparing different pieces of text to find out how similar they are. DALL-E models: these models can make images from descriptions given in words. The DALL-E models are still being tested and aren't shown in the Azure OpenAI Studio, so you don't have to set them up for use manually. Key concepts in using Azure OpenAI include prompts and completions, tokens, resources, deployments, prompt engineering, and various models. Prompts and completions: users interact with the API by providing a text command in English, known as a prompt, and the model generates a text response, or completion. For example, a prompt to count to 5 in a loop results in the model returning appropriate code. Tokens: Azure OpenAI breaks down text into tokens, which are words or character chunks, to process requests. The number of tokens affects response latency and throughput. For images, token cost varies with image size and detail setting, with low detail images costing fewer tokens and high detail images costing more. Resources: Azure OpenAI operates like other Azure products where users create a resource within their Azure subscription. Deployments: to use the service, users must deploy a model via deployment APIs, choosing the specific model for their needs. Prompt engineering: crafting prompts is crucial as they guide the model's output. This requires skill, as prompt construction is nuanced and impacts the model's response. Models: various models offer different capabilities and pricing. DALL-E creates images from text, while Whisper transcribes and translates speech to text. Each has unique features suitable for different tasks. So that's an overview of Azure OpenAI Service. The next topic we'll be covering is Azure OpenAI Studio. Developers can work with these models in Azure OpenAI Studio, a web-based environment where AI professionals can deploy, test, and manage LLMs that support generative AI app development on Azure. Access is currently limited due to the high demand, upcoming product improvements, and Microsoft's commitment to responsible AI. Presently, collaborations are being prioritized for those who already have a partnership with Microsoft, are engaged in lower risk use cases, and are dedicated to including necessary safeguards. In Azure OpenAI Studio, you can deploy large language models, provide few-shot examples, and test them in Azure OpenAI Studio's chat playground. The image shows Azure OpenAI's chat playground interface, where users can test and configure an AI chatbot. In the middle, there's a chat area to type user messages and see the assistant's replies. On the left, there's a menu for navigation and a section to set up the assistant, including a reminder to save changes. On the right, adjustable parameters control the AI's response behavior like length, randomness, and repetition. Users input queries, adjust settings, and observe how the AI responds to fine-tune its performance. So that's an overview of Azure OpenAI Studio. Let's take a look at the pricing for the models in Azure OpenAI Service. Starting off with the language models, we have GPT 3.5 Turbo with a context of 4K tokens costs $0.0015 for prompts and $0.002 for completions per 1,000 tokens. Another version of GPT 3.5 Turbo can handle a larger context of 16K tokens, with prompt and completion costs increased up to $0.003 and $0.004, respectively. GPT 3.5 Turbo 1106 with a 16K context has no available pricing. GPT-4 Turbo and GPT-4 Turbo Vision both have an even larger context size of 128K tokens, but also have no listed prices. The standard GPT-4 model with an 8K token context costs 3 cents for prompts and 6 cents for completions, and a larger context version of GPT-4 with 32K tokens costs 6 cents for prompts and 12 cents for completions. There are other models such as the base models, fine-tuning models, image models, embedding models, and speech models. They all have their respective pricing, but we won't be going through each of them in a lot of detail, but essentially they are all on a pay-per-use pricing model. It could be pay per hour or pay per token and so on. The higher quality the model, the more expensive it will likely be. So that's an overview of Azure OpenAI Service pricing. Hey, this is Andrew Brown from ExamPro, and the next topic we'll be going over are Copilots. Copilots are a new type of computing tool that integrates with applications to help users with common tasks using generative AI models. They are designed using a standard architecture, allowing developers to create custom copilots tailored to specific business needs and applications. Copilots might appear as a chat feature beside your document or file, and they utilize the content within the product to generate specific results. Creating a copilot involves several steps. Training a large language model with a vast amount of data. Utilizing services like Azure OpenAI Service, which provide pre-trained models that developers can either use as is or fine-tune with their own data for more specific tasks. Deploying the model to make it available for use within applications. Building copilots that prompt the models to generate usable content. Enabling business users to enhance their productivity and creativity through AI-generated assistance. Copilots have the potential to revolutionize the way we work. These copilots use generative AI to help with first drafts, information synthesis, strategic planning, and much more. Let's take a look at a few examples of Copilot, starting with Microsoft Copilot. So, Microsoft Copilot is integrated into various applications to assist users in creating documents, spreadsheets, presentations, and more by generating content, summarizing information, and aiding in strategic planning. It is used across Microsoft's suite of products and services to enhance user experience and efficiency. Next, we have the Microsoft Bing search engine, which has an integrated copilot to help users when browsing or searching the internet by generating natural language answers to questions by understanding the context of the questions, providing a richer and more intuitive search experience. Microsoft 365 Copilot is designed to be a partner in your workflow, integrated with productivity and communication tools like PowerPoint and Outlook. It's there to help you craft effective documents, design spreadsheets, put together presentations, manage emails, and streamline other tasks. GitHub Copilot is a tool that helps software developers, offering real-time assistance as they write code. It offers more than suggesting code snippets. It can help in thoroughly documenting the code for better understanding and maintenance. Additionally, Copilot contributes to the development process by providing support for testing code, ensuring that developers can work more efficiently and with fewer errors. So that's an overview of Copilot. Hey, this is Andrew Brown from ExamPro, and the next topic we'll be covering is prompt engineering. Prompt engineering is a process that improves the interaction between humans and generative AI. It involves refining the prompts or instructions given to an AI application to generate higher quality responses. This process is valuable for both the developers who create AI-driven applications and the end users who interact with them. For example, developers may build a generative AI application for teachers to create multiple choice questions related to text students read. During the development of the application, developers can add other rules for what the program should do with the prompts it receives. System messages. Prompt engineering techniques include defining a system message. The message sets the context for the model by describing expectations and constraints. For example, you're a helpful assistant that responds in a cheerful, friendly manner. These system messages determine constraints and styles for the model's responses. Writing good prompts. To maximize the utility of AI responses, it is essential to be precise and explicit in your prompts. A well-structured prompt, such as create a list of 10 things to do in Edinburgh during August, directs the AI to produce a targeted and relevant output, achieving better results. Zero-shot learning refers to an AI model's ability to correctly perform a task without any prior examples or training on that specific task. One-shot learning involves the AI model learning from a single example or instance to perform a task. Here is an example of prompt engineering with a user query and system response. So the user inputs, can my camera handle the rainy season if I go to the Amazon rainforest next week? Some of the prompt engineering components could be the weather resistance feature check, user's equipment database, rainforest climate data, product specifications, travel tips for photographers, etc. For the LLM processing, the AI system integrates the user's question with data about the Amazon's climate, specifically during the rainy season, and the product information about the camera's weather resistance features. It also references a database of the user's equipment to ensure it's talking about the correct item and may include travel tips that are useful for photographers heading to similar climates. And the output results in your current camera model. The ProShot Mark V is designed with a weather-sealed body suitable for high humidity and rain conditions, which matches the expected weather in the Amazon rainforest for next week. However, for added protection during heavy rains, consider using a rain cover. Next, let's take a look at the prompt engineering workflow. This image describes a simplified step process for working with AI models and prompt engineering. 1. Task understanding. Know what you want the AI to do. 2. Crafting prompts. Write instructions for the AI. 3. Prompt alignment. Make sure instructions match what the AI can do. 4. Optimizing prompt. Improve the instructions for better AI responses. 5. AI model processing. The AI thinks about the instructions. 6. Generating output. The AI gives an answer or result. 7. Output refinement. Fix or tweak the AI's answer. 8. Iterative improvement. Keep improving the instructions and answers. So that's an overview of prompt engineering. The next topic we'll be covering is grounding. Grounding in prompt engineering is a technique used in large language models where you provide specific, relevant context within a prompt. This helps the AI to produce a more accurate and related response. For example, if you want an LLM to summarize an email, you would include the actual email text in the prompt along with a command to summarize it. This approach allows you to leverage the LLM for tasks it wasn't explicitly trained on without the need for retraining the model. So, what's the difference between prompt engineering and grounding? Prompt engineering broadly refers to the art of crafting effective prompts to produce the desired output from an AI model. Grounding specifically involves enriching prompts with relevant context to improve the model's understanding and responses. Grounding ensures the AI has enough information to process the prompt correctly, whereas prompt engineering can also include techniques like format, style, and the strategic use of examples or questions to guide the AI. The image outlines a framework for grounding options in prompt engineering within the context of large language models. Grounding options, these are techniques to ensure LLM outputs are accurate and adhere to responsible AI principles. Prompt engineering, placed at the top, indicating its broad applicability. This involves designing prompts to direct the AI toward generating the desired output. Fine-tuning, a step below in complexity, where LLMs are trained on specific data to improve their task performance. Training, the most resource-intensive process, at the triangle's base, suggesting its use in more extensive customization needs. LLM ops and responsible AI, these foundational aspects emphasize the importance of operational efficiency and ethical standards across all stages of LLM application development. So that's an overview of grounding. Hey, this is Andrew Brown from ExamPro, and in this demo, we'll be going over a short demo on what you can do with Copilot with GPT-4 on Microsoft Bing. So to get here, you'll need to search for something like Copilot Bing and click on the Try Copilot, and you should be able to access this page. So on here, you have some suggested or popular prompts that people commonly use, such as create an image of a concept kitchen, generate ideas for wacky new products, how would you explain AI to a sixth grader, write Python code to calculate all the different flavor combinations for my ice cream parlor, and so on. You can choose the conversation style ranging from more creative for more original and imaginative ideas, more balanced or more precise for more factual information. We'll be going with somewhere in the middle, so more balanced, just for this example. On the bottom here, you can type in any prompt you want. So, for example, we can type something simple like summarize the main differences between supervised and unsupervised learning for the AI-900 exam. You'll see that it will start generating an answer for you. So for supervised learning, data labeling, in supervised learning, the training data is pre-labeled with the correct output values. And it provides other objectives and examples as well. And for unsupervised learning, no labels, unsupervised learning operates without labeled data. It seeks to discover patterns, structures, or relationships within the raw data. Notice how it uses sources from the internet. And if you want to learn more, you can click on these links that it provides to directly go to the source of the information, which is very convenient. So let's quickly check one out, and it seems like the information we got was pretty good and credible. And on the bottom, it also provides us some suggestions for follow-up questions you may want to ask in the future that is related to the previous prompt. Another cool feature of Copilot is that it's integrated with DALL-E 3, which is an image generation service. So, for example, you can say something like create an image of a cute dog running through a green field on a sunny day. So now you'll have to wait a little bit for it to generate the image that you described in your prompt. And there we go. We have an adorable little puppy running through the fields. You also have the power to modify images if you're not satisfied with the result. So they've provided a few options for you here. So for example, we can add a rainbow in the background, change it into a cat, or make the sky pink and purple. Let's try changing it to a cat. So it's going to generate and change it from a dog to a cat. And there we go. It's now a cute little cat running through the field. You could also write code using Copilot. So, for example, I can type in, write a Python function to check if a given number is prime. It'll start generating a piece of code for me. It can write code in multiple languages, not just Python, so let's try out something with JavaScript. Let's try create a JavaScript function to reverse a string. And of course, we'll need to wait for the code to generate. So there we go. Here's our code for the function to reverse a string, just as we asked for. So that's a really quick and general demo for Copilot with GPT-4. Hey, this is Andrew Brown from ExamPro, and in this follow along, we're going to set up a studio with an Azure machine learning service so that it will be the basis for all the follow alongs here. So what I want you to do is go all the way to the top here and type in Azure machine learning, and you're looking for this one that looks like a science bottle here, and we'll go ahead and create ourselves our machine learning studio. And so I'll create a new one here, and I'll just say my studio. And we'll hit OK, and we'll name the workspace. So we'll say my workplace. We'll maybe say ML workplace here. For containers, there are none, so it will create all that stuff for us. So I'll hit create and create. And so what we're going to do here is just wait for that creation, okay? All right, so after a short little wait there, it looks like our studio is set up. So we'll go to that resource, launch the studio, and we are now in. So there's a lot of stuff in here, but generally the first thing you'll ever want to do is get yourself a notebook going. So in the top left corner, I'm going to go to Notebooks. And what we'll need to do is load some files in here. Now they do have some sample files, like how to use Azure ML. So if we just quickly go through here, you know, maybe we'll want to look at something like MS-NIST here. And we'll go ahead and open this one. And maybe we'll just go ahead and clone this, and we'll just clone it over here. Okay, and the idea is that we want to get this notebook running, and so notebooks have to be backed by some kind of compute. So up here it says no compute found and etc. So what we can do here, and I'm just going to go back to my files. Oh, it went back there for me. But what I'm going to do is go all the way down. Actually, I'll just expand this up here, makes it a bit easier. Close this tab out. But what we'll do is go down to compute, and here we have our 4 types of compute. So compute instances is when we're running notebooks. Compute clusters is when we're doing training. Inference clusters is when we have a inference pipeline. And then attached compute is bringing things like HD Insights or Databricks into here. But for compute instances is what we need. We'll go ahead and go new. You'll notice we have the option between CPU and GPU. GPU is much more expensive, so it's like 90 cents per hour. For a notebook, we do not need anything super powerful. Notice it'll say here, development on notebooks, IDEs, lightweight testing. Here it says classical ML model training, AutoML pipelines, etc. So I want to make this a bit cheaper for us here because we're going to be using the notebook to run cognitive services, and those cost next to nothing. Like, they don't take much compute power. And for some other ones, we might do something a bit larger. But for this is good enough. So I'll go ahead and hit next. I'm just going to say my notebook instance here. We'll go ahead and hit create. And so we're just going to have to wait for that to finish creating and running. And when it is, I'll see you back here in a moment. All right, so after a short little wait there, it looks like our server is running. And you can even see here, it shows you can launch in Jupyter Labs, Jupyter VS Code, RStudio, or the terminal. But what I'm going to do is go back all the way to our notebooks just so we have some consistency here. And I want you to notice that it's now running on this compute. If it's not, you can go ahead and select it. And it also loaded in Python 3.6. There is 3.8 right now. It's not a big deal which one you use, but that is the kernel, like how it will run this stuff. Now this is all interesting, but I don't want to run this right now. What I want to do is get those cognitive services into here. So what we can do is just go up here and we'll choose editors and edit in Jupyter Lab. And what that should do is open up a new tab here. Is it opening? If it's not opening, what we can do is go to compute. Sometimes it's a bit more responsive if we just click there. It's the same way of getting to it. I don't know why, but just sometimes that link doesn't work when you're in the notebook. And what we can do is, well, we're in here now. We can see that this is where this example project is, okay? But what we want to do is get those cognitive services in here. So I don't know if I showed it to you yet, but I have a repository. I just got to go find it. It's somewhere on my screen. Here it is. Okay, so I have a repo called the free AZ9. For free AZ9, it should be AI-900. I think I'll go ahead and change that, or that is going to get confusing. Okay. So what I want you to do here is we'll get this loaded in. So this is a public directory. I'm just thinking there's a couple ways we can do it. We can go and use the terminal to grab it. What I'm going to do is I'm just going to go download the zip. And this is just one of the easiest ways to install it. And we need to place it somewhere. So here are my downloads. And I'm just going to drag it out here. Okay. And what we'll do is upload that there. So I can't remember if it lets you upload entire folders. We'll give it a go, see if it lets us. Maybe rename this to the free AZ or AI-900 there. We'll say open. Yeah, so it's individual files. So it's not that big of a deal, but we can go ahead and select it like that. And maybe I'll just make a new folder in here. We'll say this cognitive services. Okay. And what we'll do here is just keep on uploading some stuff. So we have assets. So I have a couple loose files there. And I know we have crew. Oops. We'll have crew. Oops. Sometimes it's not as responsive. We want OCR. I believe we have one called movie reviews. So we'll go into OCR here and upload the files that we have. So we have a few files there. And we'll go back a directory here. And I know movie reviews are just static files. And we have an objects folder. So we will go back here to Objects. And then we'll go back and to Crew, and we need a folder called Wharf, a folder called Crusher, a folder called Data. And so for each of these, we have some images. I think we're on Wharf, right? Yep, we are. Okay, great. So we will quickly upload all these. Oh, well, technically, we don't really need to upload any of these. Well, these images we don't, but I'm going to put them here anyway. I just remembered that these we just upload directly to the service. But because I'm already doing it anyway, I'm just going to put them here, even though we're not going to do anything with them. All right, and so now we are all set up to do some cognitive services. So I'll see you in the next video. All right, so now that we have our work environment set up, what we can do is go ahead and get cognitive services hooked up, because we need that service in order to interact with it. Because if we open up any of these, you're going to notice we have a cognitive key and endpoint that we're going to need. So what I want you to do is go back to your Azure portal, and at the top here, we'll type in cognitive services. Now, the thing is that all these services are individualized, but at some point they did group them together, and you're able to use them through a unified key and API endpoint. That's what this is, and that's the way we're going to do it. So we'll say add, and it brought us to the marketplace. So I'm just going to type in cognitive services, and then just click this one here, and we'll hit create. And we'll make a new one here. I'm just going to call it my cog services. Say OK. I prefer to be in US East. I will leave it in US West. It's fine. And so in here, we'll just say my cog services. And if it doesn't like that, I'll just put some numbers in. There we go. We'll do standard SO. We will be charged something for that. Let's go take a look at the pricing. So you can see that the pricing is quite variable here, but it's like you'd have to do 1,000 transactions before you are billed. So I think we're going to be okay for billing. We'll check boxes here. We'll go down below. It's telling us about responsible AI notice. Sometimes services will actually have you checkbox it, but in this case, it just tells us there. And we'll go ahead and hit create. And I don't believe this took very long, so we'll give it a second here. Yep, it's all deployed. So we'll go to this resource here. And what we're looking for are our keys and endpoints. And so we have 2 keys and 2 endpoints. We only need a single key. So I'm going to copy this endpoint over. We're going to go over to Juypter Lab, and I'm just going to paste this in here. I'm just going to put it in all the ones that need it. So this one needs one. This one needs one. This one needs one. And this one needs one. And we will show the key here. Well, I guess it doesn't show, but it copies. Of course, I will end up deleting my key before you ever see it, but this is something you don't want to share publicly. And usually you don't want to embed keys directly into a notebook, but this is the only way to do it. So this is how it is with Azure. So yeah, all our keys are installed. Going back to the cognitive services, nothing super exciting here, but it does tell us what services work with it. You'll see there's an asterisk beside custom vision because we're going to access that through another app. Yeah, cognitive services is all set up, and so that means we are ready to start doing some of these labs, okay? All right, so let's take a look here at computer vision first. And computer vision is actually used for a variety of different services. As you will see, it's kind of an umbrella for a lot of different things, but the one in particular that we're looking at here is to describe image in stream. If we go over here to the documentation, this operation generates description of image in a human readable language with complete sentences. The description is based on a collection of content tags, which also returned by the operation. Okay, so let's go see what that looks like in action. So the first thing is that we need to install this Azure Cognitive Services Vision Computer Vision. Now we do have a kernel, and these aren't installed by default. They're not part of the machine learning, the Azure machine learning SDK for Python. I believe that's pre-installed, but these AI services are not. So what we'll do is go ahead and run it this way. And you'll notice where it says pip install, that's how it knows to install. And once that is done, we'll go run our requirements here. So we have the OS, which is for usually handling like OS layer stuff. We have matplotlib, which is to visually plot things. And we're going to use that to show images and draw borders. We need to handle images. I'm not sure if we're using NumPy here, but I have NumPy loaded. And then here we have the Azure Cognitive Services Vision, Computer Vision. We're going to load the client. And then we have the credentials, and these are generic credentials for the Cognitive Services credentials. It's commonly used for most of these services, and some exceptions, the APIs do not support them yet, but I imagine they will in the future. So just notice that when we run something, it will show a number. If there's an asterisk, it means it hasn't ran yet. So I'll go ahead and hit play up here. So it goes an asterisk, and we get a 2, and we'll go ahead and hit play again. And now those are loaded in, and so we'll go ahead and hit play. Okay, so here we have just packaged our credentials together. So we passed our key into here, and then we'll now load in the client. And so we'll pass our endpoint and our key. Okay, so we'll hit play. And so now we just want to load our image. So here we're loading assets data.jpg. Let's just make sure that that is there. So we go assets, and there it is. And we're going to load it as a stream because you have to pass streams along. So we'll hit play, and you'll see that it now ran. And so now we'll go ahead and make that call. Okay, great. And so we're getting some data back. And notice we have some properties: person, wall, indoor, man, pointing, captions. It's not showing all the information. Sometimes you have to extract it out, but we'll take a look here. So this is a way of showing matplotlib in line. I don't think we have to run it here, but I have it in here anyway. And so what it's going to do is it's going to show us the image, right? So it's going to print us the image. And it's going to grab whatever caption is returned. So see how there's captions? So we're going to iterate through the captions. It's going to give us a confidence score saying it thinks it's this. So let's see what it comes out with. Okay, and so here it says Brent Spiner looking at a camera. So that is the actor who plays Data on Star Trek, has a confidence score of 57.45%, even though it's 100% correct. They probably don't know contextual things like in the sense of like pop culture, like they don't know probably Star Trek characters, but they're going to be able to identify celebrities because it's in their database. So that is the first introduction to computer vision there. But the key things you want to remember here is that we use this to describe an image stream, and that we get this confidence score and we get this contextual information. Okay, and so that's the first one. We'll move on to maybe custom vision next. All right, so let's take a look at custom vision so we can do some classification and object detection. So the thing is that it's possible to launch custom vision through the marketplace. So if we go, we're not going to do it this way. If you type in custom vision, it never shows up here. But if you go to the marketplace here and type in custom vision, and you go here, you can create it this way. But the way I like to do it, and I think it's a lot easier to do, is we'll go up the top here and type in customvision.ai, and you'll come to this website. And what you'll do is go ahead and sign in. It's going to connect to your Azure account. And once you're in, you can go ahead here and create a new project. So the first one here is, I'm just going to call this the Star Trek crew. We're going to use this to identify different Star Trek members. We'll go down here, and we haven't yet created a resource, so we'll go create new. My custom vision resource. We'll drop this down. We'll put this in our cog services. We'll go stick with US West as much as we can here. We have FO and SO. FO is blocked out for me, so just choose SO. I think FO is the free tier, but I don't get it. And once we're back here, we'll go down below and choose our standard. And we're going to have a lot of options here. So we have between classification and object detection. So classification is when you have an image and you just want to say, what is this image, right? And so we have two modes where we can say, let's apply multiple labels. So let's say there were two people in the photo, or whether there was a dog and cat. I think that's the example to use, a dog and a cat. Or you just have a single class where it's like, what is the one thing that is in this photo? It can only be of one of the particular categories. This is the one we're going to do multi-class. And we have a bunch of different domains here. And if you want to, you can go ahead and read about all the different domains and their best use case. But we're going to stick with A2. And this is optimized for, so that it's faster, right? And that's really good for our demo. So we're going to choose General A2. I'm going to go ahead and create this project. And so now what we need to do is start labeling our content. So what we'll do is I just want to go ahead and create the tags ahead of time. So let's say wharf. We'll have data, and we'll have crusher. And now what we'll do is we'll go ahead and upload those images. So, we uploaded in the Juypter Notebook, but it was totally not necessary. So here is data, because we're going to do it all through here. And we'll just apply the data tag to them all at once, which saves us a lot of time. I love that. We'll upload now wharf. And I don't want to upload them all. I have this one quick test image we're going to use to make sure that this works correctly. And I'm going to choose wharf. And then we'll go ahead and add Beverly. There she is. Beverly Crusher. Okay, and so we have all of our images in. I don't know how this one got in here, but it's under wharf. It works out totally fine. So what I want to do is go ahead and train this model, because they're all labeled, so we have a ground truth, and we'll let it go ahead and train. So we'll go and press train. And we have two options, quick training or advanced training. Advanced training, where we can increase the time for better accuracy. But honestly, we just want to do quick training. So I'll go ahead and do quick training. And it's going to start its iterative process. Notice on the left-hand side, we have probability threshold, the minimum probability score for a prediction to be valid when calculating precision, and recall. So the thing is that if it doesn't at least meet that requirements, it will quit out. And if it gets above that, then it might quit out early just because it's good enough. Okay, so training doesn't take too long. It might take 5 to 10 minutes. I can't remember how long it takes, but what I'll do is I'll see it back here in a moment. Okay. All right, so after waiting a short little while here, it looks like our results are done. We get 100% match here. So these are our evaluation metrics to say whether the model was achieved its actual goal or not. So we have precision, recall, and I believe this is average precision. And so it says that it did a really good job. So that means that it should have no problem matching up an image. So in the top right corner, we have this button that's called Quick Test, and this is going to give us the opportunity to quickly test these. So what we'll do is browse our files locally here. And actually, I'm going to go to, we'll go here, and we have wharf. And so I have this quick image here. We'll test, and we'll see if it actually matches up to be wharf. And it says 98.7% wharf, so that's pretty good. I also have some additional images here I just put into the repo to test against, and we'll see what it matches up, because I thought it'd be interesting to do something that is not necessarily them, but it's something pretty close to, it's pretty close to what those are, okay? So we'll go to crew here, and first we'll try Hugh, okay? And Hugh is a Borg, so he's kind of like an android, and so we can see he mostly matches to data, so that's pretty good. We'll give another one go. Martok is a Klingon, so he should be matched up to Worf. Very strong match to Worf. That's pretty good. And then Pulaski, she is a doctor and female, so she should get matched up to Beverly Crusher, and she does. So this works out pretty darn well. And I hadn't even tried that, so that's pretty exciting. So now let's say we want to go ahead and, if we wanted to make predictions, we could do them in bulk here. I believe that you could do them in bulk. But anyway, yeah, I guess I always thought this was like, I could have swore, yeah, if we didn't have these images before, I think that it actually has an upload option. It's probably just the quick test, so I'm a bit confused there. But anyway, so now that this is ready, what we can do is go ahead and publish it so that it is publicly accessible. So we'll just say here, crew model. Okay, and we'll drop that down, say publish. And once it's published, now we have this public URL. So this is an endpoint that we can go hit pragmatically. I'm not going to do that. I mean, we could use Postman to do that. But my point is that we've basically figured it out for classification. So now that we've done classification, let's go back here to the vision here. And let's go ahead and do object detection, okay? All right, so we're still in custom vision. Let's go ahead and try out object detection. So object detection is when you can identify particular items in a scene. And so this one's going to be COM badge. That's what we're going to call it, because we're going to try to detect COM badge. We have more domains here. We're going to stick with the general A1. And we'll go ahead and create this project here. And so what we need to do is add a bunch of images. I'm going to go ahead and create our tag, which is going to be called ComBadge. You could look for multiple different kinds of labels, but then you need a lot of images. So we're just going to keep it simple and have that there. I'm going to go ahead and add some images, and we're going to go back a couple steps here into our objects. And here I have a bunch of photos, and we need exactly 15 to train. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so I threw an additional image in here. This is the badge test. So we'll leave that out, and we'll see if that picks up really well. And yeah, we got them all here. And so we'll go ahead and upload those, and we'll hit upload files. Okay. And we'll say done. And we can now begin to label. So we'll click into here. And what I want to do, if you hover over, it should start detecting things. If it doesn't, you can click and drag. We'll click this one. They're all com badges. So we're not going to tag anything else here. Okay. So go here, hover over. Is it going to give me the com badge? No. So I'm just clicking and dragging to get it. Okay. Okay. Did we get this com badge? Yes. Did we get this one? Yep. It's as simple as that. Okay, it doesn't always get it, but most cases it does. Okay, didn't get that one, so we'll just drag it out. Okay, it's not getting that one. It's interesting, like that one's pretty clear, but it's interesting what it picks out and what it does not grab, eh? So it's not getting this one, probably because the photo doesn't have enough contrast. And this one has a lot. Hoping that gives us more data to work with here. Yeah, I think the higher the contrast, it's easier for it to detect those. It's not getting that one. It's not getting that one. Okay, there we go. Yes, there are a lot. I know I have some of these ones that are packed, but there's only like 3 photos that are like this. Yeah, they have badges, but they're slightly different, so we're going to leave those out. Oops, I think it actually had that one, but we'll just tag it anyway. And hopefully this will be worth the effort here. There we go. I think that was the last one. Okay, great. So we have all of our tagged photos, and what we can do is go ahead and train the model. Same option, quick training, advanced training. We're going to do a quick training here. And notice that the options are slightly different. We have probability threshold, and then we have overlap threshold. So the minimum percentage of overlap between predicted bounding boxes and ground truth boxes to be considered for correct prediction. So I'll see you back here when it is done. All right, so after waiting a little bit of while here, it looks like it's done, it's trained, and so precision's at 75%. So precision, the number will tell you if a tag is predicted by your model, how likely that it's likely to be. So how likely did it guess right? Then you have recall. So the number will tell you out of the tags which should be predicted correctly, what percentage did your model correctly find? So we have 100%. And then you have mean average precision. This number will tell you the overall object detector performance across all the tags. Okay, so what we'll do is we'll go ahead and do a quick test on this model, and we'll see how it does. I can't remember if I actually even ran this, so it'll be curious to see. The first one here, it's not as clearly visible. It's part of their uniform, so I'm not expecting it to pick it up, but we'll see what it does. It picks up pretty much all of them, with the exception this one is definitely not a com badge, but that's okay. Only shows suggested obviously the probability is above the selected threshold. So if we increase it, we'll just bring it down a bit. So there it kind of improves it if we move it around back and forth, okay? So I imagine via the API we could choose that. Let's go look at our other sample image here. I'm not seeing it. Where did I save it? Let me just double check, make sure that it's in the correct directory here, okay? Yeah, I saved it to the wrong place. Just a moment. I will place it. We'll just call that bench test 2. 1 second. Okay, and so I'll just browse here again. And so here we have another one. See if it picks up the badge right here. There we go. So looks like it works. So yeah, I guess custom vision is pretty easy to use and pretty darn good. So what we'll do is close this off and make our way back to our Jupyter labs to move on to our next lab here, okay? All right, so let's move on to the face service. So just go ahead and double click there on the left-hand side. And what we'll do is work our way from the top. So the first thing we need to do is make sure that we have the computer vision installed. So the face service is part of the computer vision API. And once that is done, we'll go ahead and do our imports. Very similar to the last one, but here we're using the face client. We're still using the cognitive service credentials. We will populate our keys. We'll make the face client and authenticate. And we're going to use the same image we used prior with our computer vision, so the data one there. And we'll go ahead and print out the results. And so we get an object back. So it's not very clear what it is, but here, if we hit show, okay, here it's data and it's identifying the face ID. So going through this code, so we're just saying open the image. We're going to set up our figure for plotting. It's going to say, well, how many faces did it detect in the photo? And so here it says detected one face. It will iterate through it, and then we will create a bounding box around the images. We can do that because it returns back the face rectangle. So we get a top, left, right, etc. And we will draw that rectangle on top. So we have magenta. I could change it to like 3 if I wanted to. I don't know what the other colors are, so I'm not even going to try, but yeah, there it is. And then we annotate with the face ID. That's the unique identifier for the face. And then we show the image, okay? So that's one. And then if we wanted to get more detailed information like attributes such as age, emotion, makeup, or gender, this resolution image wasn't large enough. So I had to find a different image and do that. So that's one thing you need to know, as if it's not large enough, it won't process it. So we're just loading data large. Very similar process, but it is the same thing, detect with stream, but now we're passing in return face attributes. And so here we're saying the attributes we want. And there's that list, and we went through it in the lecture content. And so here we'll go ahead and run this. And so we're getting more information. So that magenta line is a bit hard to see. I'm just going to increase that to 3. Okay. Still really hard to see, but that's okay. So approximate age, 44. I think the actor was a bit younger than that. Data technically is male presenting, but he's an android, so he doesn't necessarily have a gender, I suppose. He actually is wearing a lot of makeup, but all it detects is, I guess it's only particular on the lips and the eyes. So it says he doesn't have makeup. So maybe there's like color, you know, like eyeshadow stuff. Maybe we would detect that. In terms of personality, I like how he's a 0.02% SAB, but he's neutral, right? So just going through the code here very quickly. So again, it's the number of faces. So it detected one face. And then we draw a bounding box around the face. For the detected attributes, it's returned back in the data here. So we just say, get the face attributes, turn it into a dictionary, and then we can just get those values and iterate over it. So that's as complicated as it is. And so there we go. All right, so we're on to our next cognitive service. Let's take a look at Form Recognizer. All right, and so Form Recognizer, it tries to identify like forms and turns them into readable things. And so they have one for receipts in particular. So at the top, finally, we're not using computer vision. We actually have a different one. So this one's Azure AI Form Recognizer. So we'll run that there. But this one in particular isn't up to date in terms of using it like... notice all the other ones, they're using the cognitive service credential. So for this, we actually had to use the Azure key credential, which was annoying. I tried to use the other one to be consistent, but I couldn't use it, okay? So what we'll do is run our keys like before. We have a client, very similar process. And this time we actually have a receipt. And so we have begin recognize receipt. So it's going to analyze the receipt information. And then what it's going to do is show us the image. Okay, just so we have a reference to look at. Now the image isn't actually yellow, it's a white background. I don't know why when it renders out here it does that, but that's just what happens. And it even obscures the server name. I don't know why. But anyway, if we go down below, this is return results up here, right? So we got our results. And so if we just print out the results, here we can see we get a recognized form back. We get fields and some additional things. And if we go into the fields itself, we see there's a lot more information. If you can make out, like here, it says merchant phone number, form field, label, value, and there's the number 512707. So for these things here, like the receipts, if we can just find the API quickly here, it has predefined fields. I'm not sure, yeah, business card, etc. Like if we just type in merchant, I'm just trying to see if there's a big old list here. It's not really showing us a full list, but these are predefined things that are returned, right? So they've defined those, maybe it's over here. There we go. So these are the predefined ones that extracts out. So we have receipt type, merchant name, et cetera, and so if we go back to here, you can see I have the field called merchant name. So if we hit there, it says Alamo Draft Out Cinema. Let's say we wanted to try to get that balance. Maybe we can try to figure out which one it is. I never ran this myself when I made it, so we'll see what it is. But here it has total price. What's interesting is that this has a space. So it's kind of unusual. You think it'd be together, but let's see if that works. Okay, doesn't like that. Maybe that's just a typo on their part. Okay, so we get none. Let's try price. See what it picks up. Nope, nothing. We know that the phone number is there, so we'll give the phone number. There we go. So, you know, it's an okay service, but your mileage will vary based on what you do there. Maybe we could try total, because that makes more sense, right? Yeah, there we go. Okay, great. So yeah, it is pulling out the information. And so that's pretty much all you need to know about that service there, okay? Let's take a look at some of our OCR capabilities here. And I believe that's in Computer Vision, so we'll go ahead and open that up. At the top here, we'll install Computer Vision as we did before. Very similar to the other Computer Vision tasks, but this time we have a couple of ones here. Then I'll explain that as we go through here. We'll load our keys. We'll do our credentials. We'll load the client. Okay, and then we have this function here called printed text. So what this function is going to do is it's going to print out the results of whatever text it processes, okay? So the idea is that we're going to feed in an image, and it's going to give us back out the text for the image. So we'll run this function. And I have two different images because I actually ran it on the first one and the results were terrible. And so I got a second image and it was a bit better. Okay, so we'll go ahead and run this. It's going to show us the image. Okay, and so this is the photo. It was supposed to extract out Star Trek The Next Generation, but because of the artifacts and size of the image, we get back not English. Okay, and so, you know, maybe a high resolution image, it would have a better time there. But that is what we got back, okay? So let's go take a look at our second image and see how it did. And this one, I'm surprised that it actually extracts out a lot more information. You can see, it really has a hard time with the Star Trek font, but we get Deep Space Nine, Nana Visitor, Tells All, Life, Death. Some errors here, so it's not perfect. But, you know, you can see that it does something here. Now, there is this is like for OCR, where we have, like for very simple images and text, this is where we use the recognize printed text in stream. But if we're doing this for larger amounts of text and we want to do this, want this analyzed asynchronously, then we want to use the read API. And it's a little bit more involved. So what we'll do here is load a different image. And this is a script. We'll look at the image here in a moment. But here we read and stream. And we create these operations. Okay. And what it will do is it will asynchronously send all the information over. Okay. So I think this is supposed to be results here. Minor typo. And we will go ahead and give that a run. Okay. And so here you can see it's extracting out the image. If we want to see this image, I thought I showed this image here, but I guess I don't. Yeah, it says plot image here. It should show us the image. Path. It's up here. It doesn't want to show us. It's funny because this one up here is showing us no problem, right? Well, I can just show you the image. It's not a big deal. But I'm not sure why it's not showing up here today. So if we go to our assets here, I go to OCR. I'm just going to open this up. Oh, it's opening up in Photoshop. And so this is what it's transcribing, okay? So this is a thing. This is like a guide to Star Trek where they talk about, like, you know, what makes Star Trek Star Trek. So just looking here, it's actually pretty darn good. Okay, but like Read API is a lot more efficient because it can work asynchronously, and so when you have a lot of text, that's what you want to do. Okay, and like it's feeding in each individual line, right? So that it can be more effective that way. So let's go look at some handwritten stuff. So just in case the image doesn't pop up, we'll go ahead and open this one. And so this is a handwritten note that William Shatner wrote to a fan of Star Trek. And it's basically incomprehensible. I don't know if you can read that here, but see, was very something, he was something hospital, and healthy was something, he was something. I can't even read it. Okay, so let's see what the machine thinks here. And it says image path. Yeah, it's called path. Let's just change that out. Go ahead and run that. And run that there. And we'll go ahead and run it. And here we get the image. So, Poner, us, very sick. He was the hospital. His BD was, etc. Beat nobody, lost his family, knew Captain Halden. So reads better than how I could read it. Honestly, like it's really hard, right? Like if you looked at this, like that looks like difficult, was, BD, healthy. I could see why it's guessing like that, right? Dying, that looks like dying to me. You know what I mean? So, you know, it's just poorly handwritten, but I mean, it's pretty good for what it is. So, yeah, there you go. All right, so let's take a look at another cognitive service here. And this one is text analysis. And so what we'll do is install the Azure Cognitive Services language text analytics here. So we'll go ahead and hit run. All right. And once that's installed, this one actually is using the Cognitive Services credentials, so it's a little bit more standard with our other ones here. We'll go ahead and run that there. We'll make our credentials, load our client. And this one, what we're going to do is try to determine sentiment and understand why people like a particular movie or not. So I've loaded a bunch of reviews. They are, again, I can show you the data if it helps. And so I'm just trying to find my right folder here. And so if we go back, look at our movie reviews, here's like a review someone wrote. First Contact just works. It works as a rousing chapter in the Star Trek. To a lesser extent, it works as a mainstream entertainment. So different reviews for Star Trek First Contact, which was a very popular movie back in the day. So what we'll do is we will load the reviews. So it's just iterating through the text files and showing us what the reviews are. So here we can see all the written text. Had a lot of trouble getting the last one to display, but it does get loaded in. And so here we're using the text analysis to show us key phrases, because maybe that would give us an indicator. And so that's the object back, but maybe that would give us an indicator as to like what people are saying as important things. So here we see Borg ship, Enterprise, smaller ship escapes, neutral zone, travels, contact damage, co-writer, beautiful mind, sophisticated science fiction, best, whales, Leonard Nimoy. Okay. Wealth of unrealized potential, filmmaker John Franks. Okay. So very interesting stuff as it here. Borg ship again. You're seeing Borg ship a lot. So that is kind of key phrases. Let's go get customer sentiment, or how people felt about it. Did they like it or not? And so here we just call sentiment. And what we'll do is if it's above 5, then it's positive, and it's below 5, then it's a negative review. I think most people thought it was a very good film. So this one says it's pretty low, 9. So let's go take a look at that one. It wasn't actually showing rendered there, so maybe we'll have to open it up manually. See if that's actually accurate. It's empty, so there you go. I guess we had a blank one in there. I must have forgot to paste it in, but that's okay. That's a good indicator that, you know, that's what happens if you don't have it. So let's look at number 1 then, which is, well, actually this one is 9. This is 0, 4. This one here is 8. So we'll open up 8. When the Borg launch on Earth, the Enterprise is sent to the neutral zone, etc., etc. However, a smaller ship escapes travel. The Enterprise follows back. Meanwhile, the survivors. So, like, this is a synopsis. It doesn't say whether they like it or they don't, but it was just 04. I guess so. There's nothing positive about it, right? If we look at one that was, this one's pretty low, which is, no, it's not. It's 1. So it seems like this person probably really liked it. Or no, I guess that's actually pretty low because it's 1. It's not 9. 9's very high. Let's take a look at this one. Review number 2. If we go up here, the doggo has improved the story elements during the show, but there's a wealth of unrealized potential. So that's a fair one, saying that maybe they don't like it as much. I don't know if they give it 2 stars, right? We could probably actually correlate it with the actual results, because I did get these off of IMDb and Rotten Tomatoes. But yeah, there you go. That is text analysis. All right, so now we're on to QnA Maker, and so we're not going to need to do anything programmatically because QnA Maker is all about no code or low code to build out a questions and answers bot service. So what we'll do is go all the way up to here, and I want you to type in QnMaker.ai because as far as I'm aware of, it's not accessible through the portal. Sometimes you can find these things, again, if we go to the marketplace. I'm just curious, I'm going to just take a look here really quickly. Whenever it decides to log us in here. Okay, great. So I'll go over to Marketplace. And probably if we type in QnA, maybe we'd see something here. QnA. Yeah, so we go here. Give it a second here. Seems like Azure is a little bit slow right now. It usually varies fast, but you know, the service varies. Well, it's not loading for me right now, but that's okay because we're not going to do it that way anyway. Again, go to QnMaker.ai, and what I want you to do is go all the way to the top in the right corner, and we'll hit sign in. And what we'll be doing is connecting via our single sign-on with our account, so it already knows I have an account there. I'm going to give it a moment here, and I'm going to go ahead and just give it a second. There we go. So it says I don't have any knowledge bases, which is true. So let's go ahead and create ourselves a new knowledge base. Here we have the option between stable and preview. I'm going to stick with stable because I don't know what's in preview. I'm pretty happy with that. And so we need to connect QnA service to our knowledge base. And so back over here in Azure, actually, I guess we do have to make one. Now that I remember, we actually have to create a QnA Maker service. So I'll go down here and put this under my cog services. We'll say my QnA service. Might complain about the name. Yep, so I'll just put some numbers here. We will pick free tier sounds good, so I'll go free. When I actually get the option, that's what I will choose. Down below, we'll choose free again. US East sounds great to me. It generates out the name. It's the same name as here, so that's fine. We don't need App Insights, but I'm going to leave it enabled because I think it changes it to standard or S0 when you do not have it enabled, unusually. And so we will create our QnA Maker service. Give it a moment here. And it says, I remember it will say, like, even if you try, you might have to wait 10 minutes for it to create the service. So even after it's provisioned, it'll take some time. So what we should do is prepare our doc because it can take in a variety of different files. And I just want to show you here that the QnA, they have a whole paper here formatting the guidelines. And basically, it's pretty smart about knowing where headings and answers is. So for unstructured data, we just have a heading and we have some text. So let's write some things in here that we can think of. Since we're all about certification, we should write some stuff here. So how many AWS certifications are there? I believe right now there are 11 AWS certifications. Okay. And maybe if we use our headings here, this would probably be a good idea here. Yep. Okay. Another one could be how many fundamental Azure certifications are there? And we'll give this a heading. We'll say there are 3 Azure, I think there's 3, there's other ones, right? Like Power Platform stuff, but just being Azure specific, there are 3 Azure fundamental certifications. So we have the DP900, the AI900, the AZ900. I guess there's 4. There's the SC900, right? So there are 4. Okay. We'll say which is the hardest Azure Association certification. And what we'll say here is, I mean, it's my opinion is it's the Azure Administrator. Had some background noise there, that's why I was a bit pausing there, but the Azure Administrator AZ104, I would say that's the hardest. Which is harder? The AWS or Azure certifications. I'd say Azure certifications are harder because they check exact steps for implementation, where AWS focuses on concepts. Okay, so we have a bit of a knowledge base here, so I'll save it. And assuming that this is ready, because we need a little bit of time to put this together, we'll go back to QnA, can hit a refresh here, give it a moment, drop it down, choose our service. And notice here that we have chit chat extraction and only extraction. We're going to do chit chat. I would say this will be the reference name be changed any time. This will be like certification QnA. And so here we want to populate. So we'll go to files here. I'm going to go to my desktop. And here it is. I'll open it. We will choose professional tone. Go ahead and create that. And so I'll see you back here in a moment. All right, so after waiting a short little time here, it loaded in our data, so you can see that it figured out which is the question, which is the answer, and it also has a bunch of defaults. So here, if somebody was asked something very silly, like can you cry, I'll say I don't have a body. It has a lot of information preloaded for us, which is really nice. If we wanted to go ahead and test this, we could go and say, we'll go here, and then we'll write in, we could say like hello. I say boring. This is good morning. Okay, so we'll say how many certifications are there? We didn't say AWS, but let's just see what happens. And so it kind of inferred, even though we didn't say AWS in particular. So I noticed that there's AWS and Azure. So how many fundamental Azure certifications, things like that. And so it chose AWS. So it's not like the perfect service, but it's pretty good. I wonder what would happen if we placed in one that's like Azure. I don't know how many Azure certs there are. We'll just say like there's 11, 12. I can never remember. They're always adding more. But it does, I want to close this here. There we go. So let's just go add a new key pair here. And we'll say how many Azure certifications are there? I should have said certifications. I'll probably just set in one moment. So there are 12 Azure certifications. Who knows how many they have? They could have like 14 or something. We could say like between 11 and 14. They just add them. They just update them too frequently. I can't keep track. So we'll go here and we'll just say certifications, and we will save and retrain. So we'll just wait here a moment. Great, and so now we'll go ahead and test this again. So we'll say, how many certifications are there? And see, it's pulling the first answer. If I say Azure, let's see if it gets the right one here. How many Azure certifications are there? Okay. So, maybe you'd have to have a generic one for that match. So if we go back here and we say, how many certifications are there? You say, which certification, which cloud service provider? Okay, we got AWS, Azure. Follow prompt. You can use guides through conversational flow. Prompts are used to link QnA pairs and can be displayed. I haven't used this yet, but I mean, it sounds like something that's pretty good because there is multi-turn in this. So the idea is that if you had to go through multiple steps, you could absolutely do that. We could try this a little bit here. Follow prompt you can use to guide. Prompts are used to link QnA pairs together. Text or button for suggested action. Oh, okay. So maybe we would just do like AWS, link to QnA, and then so search an existing QnA or create a new one. So it'd say like how many AWS. Ooh, okay, we're typing it in. Context only, this follows up, will not be understood out of the context flow. Sure, because it should be within context, right? And here we can do another one. We say like Azure. We'll say how many Azure. Context only. Whoops, it got away from me there. We'll save that. And what we'll do is save and train. So we'll go back here and we'll say, how many certifications are there? Enter. So we have to choose AWS. And so there we go. So we got something that works pretty good there. Since I'm happy with it, we can go ahead and go and publish that. So we'll say publish. And now that it's published, we could use Postman or curl to trigger it. But what I want to do is create a bot, because with Azure Bot Services, then we can actually utilize it with other integrations, right? It's a great way to use your bot or to actually host your bot. So we'll go over here. It'll link it over. If you don't click it, it doesn't preload it in. So it's kind of a pain. If you lose it, you have to go back there and click it again. But let's just say certification QnA. And we will look through here. So I'm going to go with free, premium messages, 10K, 1K premium message units. I'm kind of confused by the pricing, but F0 usually means free, so that's what I'm going to go for that. SDK or Node.js. I'm going to use Node.js. Not that we're going to do anything there with it. We'll go ahead and create that. And I don't think this takes too long. We'll see here. And just go ahead and click on that there. I'll just wait here a bit. I'll see you back here in a moment. All right, so after waiting, I don't know, about 5 minutes there, it looks like our bot service is deployed. We'll go to that resource there. You can download the bot source code. Actually, I never did this, so I don't know what it looks like, so I'd be curious to see this, just to see what the code is. I assume that because we chose Node.js, it would give us that as the default there. So download your source code as your bot, creating the source zip. Not sure how long this takes. Might be regretting clicking on that, but what we'll do is we'll go on the left-hand side here to channels, because I just want to show here. Yeah, didn't download. We'll try here in a second, but what we'll do is we'll go back. Bot profile, unspecified bot. What are you talking about? Yeah, maybe it needs some time. So, maybe we'll just give the bot a little bit of time here. I'm not sure why it's giving us a hard time, because this bot is definitely deployed. If we go over to our bots, right? Bot services, it is here. Sometimes there's like latency, with Azure. And oh, there we go. Okay, see, it works now fine, right? And so I want to show you that there's different channels, and these are just easy ways to integrate your bot in different services. So whether you wanted to use it with Alexa, GroupMe, Skype, Telephony, Twilio, Skype, Business, Apparently they don't have that anymore because I guess it's all Teams now, right? Keek, which I don't know if people still use that. Slack, which is that Discord, Telegram, Facebook, email. That's kind of cool. But Teams is a really good one. I use Teams. There's a direct line channel. I don't know what that means. And there's web chat, which is just having like an embed code. So if we go over, we can go and test it over here. Just start testing our web chat. And so it's the same thing as before, but we could just say things like, how many certifications are there? Let's say like Azure and get a clear answer back. We'll go back up to our overview. Let's try to see if we can download that code again. I was kind of curious what that looks like. If it will download. Must be a lot of code, eh? There we go. So now we can hit download. And so there is the code. I'm going to go ahead and open that up. So yeah, I guess when we chose JavaScript, that made a lot more sense. Let's give it a little peek here. I'm just going to drop this on my desktop here. So let's make a new folder here and call this bot code. Okay, I know you can't see what I'm doing here, but let's go here and double click into here and then just drag that code on in. And then what we can do is open this up in VS Code. I should have VS Code running somewhere around here. I'm just going to go ahead and open that. I'm off screen here. I'll just show you my screen in a moment. Say show code. Oops. File, open folder, bot code, okay. And we'll come all the way back here. And so we've got a lot of code here. Never looked at this before, but you know, I'm a pretty good programmer, so it's not too hard for me to understand. So it looks like you got an API request, things like that. I guess it would just be like if you needed to integrate into your application, then it kind of shows you all the code there. I'm just trying to see our dialog choices. Nothing super exciting. Okay. You know, when I go and make the, was it the AI or the AI-100, whatever the data scientist course is, I'm sure I'll be a lot more thorough here, but I was just curious as to what that looks like. Now, if we wanted to have an easy integration, we can get an embed code for this. So if we go back to our channels, I believe we can go and, is it edit? Ah, yes. So here we have a code. So what I'll do is go back to Jupyter Labs. I'm just going to go make a new empty notebook. So we'll just go up here and say notebook. And this can be for our QnA. Doesn't really matter what kernel. We'll say QnA Maker. Just show like if you wanted a very, very simple way of integrating your bot, we would go back over to wherever it is here. Here we are. I'm going to go ahead and copy this iframe. I think it's percentage HTML. So it treats this cell as HTML. And I don't have any HTML to render, so we will place that in there. And notice we have to replace our secret key. So I will go back here and I will show my key and we will copy that. And we will paste that key in here. And then we'll run this. And I can type in here. Where am I? Just ask silly things. Who are you? How many Azure certifications are there? Well, I wonder if I just leave the are there off. Let's see if it figures it out. Okay, cool. So, yeah, I mean, that's pretty much it with QnA Maker. So, yeah, that's great. So I think we're done here, and we can move on to checking out LUIS, or LUIS, Learning Understanding, to make a more robust bot, okay? All right, so we are on to our last cognitive service, and this one is going to be LUIS, or LUIS, depending on how you like to say it. It's LUIS, which is language understanding. So you type in luis.ai, and that's going to bring us up to this external website. It's still part of Azure, just it has its own domain. And so here we'll choose our subscription. And we have no authoring source, so I guess we'll have to go ahead and create one ourselves. So go down here and we'll choose my cognitive services, Azure resource name, so my auth service, or my cognitive service. Create new cognitive service account. But we already have one, so I don't want to make another one, right? It should show up here, right? Or valid in the authoring region. So it's possible that we're just in the incorrect region. So we might end up creating two of these. And that's totally fine. I don't care. It's as long as we get this working here, because we're going to delete everything at the end anyway. And so just say my cog service 2. And we'll say West US, because I think that maybe we didn't choose one of these regions. Let's go double check. If we go back to our portal, just the limitations of the service, right? So we'll go to my cog services here. I just want to go cognitive services. So just want to see where this is deployed. And this is in West US. Yeah, so I don't know why it's not showing up there, but whatever. If that's what it wants, we'll give it what it wants, okay? Shouldn't give us that much trouble, but hey, that's how it goes. And so we have an authoring service. I'm going to refresh here and see if it added a second one. It didn't, so all right. That's fine. So we'll just say my sample bot. We'll use English as our culture. If nothing shows up here, don't worry. You can choose it later on. I remember the first time I did this, it didn't show up. And so now we have my cog service, my custom vision service. We want cog service. So anyway, it tells you about schema, like how you make a schema and animates, talking about like bot action intent and example utterance. But we're just going to set up something very simple here. So we're going to create our intent. The one that we always see is flight booking. So I'll go here and do that. And what we want to do is write an underline. So like book me a flight to Toronto. Okay. And so if someone were to type that in, then the idea is it would return back the intent, this value and metadata around it, and we could pragmatically provide code, right? So what we need is identities, and we can actually just click here and make one here. So enter named identity. We'll just call this location. Okay. Here we have an option machine learned and list. If you flip between it, this is like, imagine you have a ticket order and you have these values that can change. Or you just have a value that always stays the same, like list. So that's our airport. If that makes sense, we'll do that. If we go over to entities, we can see it here. All right, so nothing super exciting there. But what I want to show you is if we go ahead and we should probably add flight booking. Should be, how about book flight? Flight booking. Flight booking. Okay, so we'll go ahead, and I know there's only one, but we'll go ahead and train our model. Because we don't need to know tons, right? We covered a lot in the lecture content. To build a complex bot is more for the associate level. But now what we can do is go ahead and test this, and we'll say, book me a flight to Seattle. Okay, and notice here it says book flight. We can go inspect it, and we get some additional data. So top scoring, so it says how likely that was the intent. Okay, so you get kind of an idea there. There's additional things here. It doesn't really matter. We'll go back here, and we will go ahead and publish our model. So we can put it into a production slot. You can see we have sentiment analysis, speech priming. We don't care about either of those things. We can go and see where our endpoint is. And so now we have an endpoint that we can work with. So yeah, I mean, that's pretty much all you really need to learn about Lewis. But I think we're all done for cognitive services. So we're going to keep around our notebook because we're going to still use our Juypter Notebook for some other things. But what I want you to do is make your way over to your resource groups. Because if you've been pretty clean, it's all within here. We'll just take a look here. So we have our QnA, all of our stuff here. I'm just making sure it's all there. And so I'm just going to go ahead and delete this resource group, and that should wipe away everything, okay? For the cognitive services part. All right, so we're all good here. And I'm just going to go off and I'll leave this open because it's always a pain to get back to it and reopen it. But let's make our way back to the home here in the Azure Machine Learning Studio. And now we can actually explore building out machine learning pipelines. Okay, so we are on to the ML follow-alongs here. So we're going to learn how to build some pipelines. The first, I think, is the easiest, would be automated ML, or also known as AutoML. The idea here is it's going to just build out the entire pipeline for us. So we don't have to do any thinking. We just say what kind of model we want to run and have it to make a prediction. So what we'll do is say new automated ML. And we're going to need a data set. So I don't have one, but the nicest thing is they have these open data sets. So if you click here, you'll see there is a bunch here. And a lot of these you'll come across quite often, not just on Azure, but other places. Like this diabetes one, I've seen it like everywhere, okay? And so like if we just go click here, maybe we can read a bit more here. So diabetes dataset, 422 samples with 10 features, ideal for getting started with machine learning algorithms. It's one of the popular scikit-learn toy datasets. It's probably where I've seen it before, though it's not showing up there. You scroll on down, you can see the data. You notice that it's available in Azure Notebooks, Databricks, and Azure Synapse. The thing is we have these values, so age, sex, BMI, BP, and the Y is trying to make a prediction. It's trying to say, what's the likelihood of you having diabetes or not? And so it's not a Boolean value, so it's not a binary classifier. It's kind of on a, well, I guess you be doing binary classification to say, do you have diabetes? Or you can make a prediction to say, what's the likelihood or this value if you gave another value in there. But anyway, this is the predicting value. A lot of times this is X, so everything here is X, and this is considered Y, the actual prediction. So sometimes it's Y, and sometimes it's actually named what it is, but that's just what it is here. So we'll close that off, and so we'll choose the diabetes set, and it will be data set 1. And so we'll worry about feedback later. So we'll click on sample diabetes. We'll hit next. And here it's going to try to figure out what kind of model that we want. We have to create a new experiment. It's a container to run the model in. So we'll just say diabetes. It's my diabetes. It sounds a bit odd, but that's what it is. The target column we want to predict is, seeing the train to predict is the Y. It's usually the Y. We don't have a compute cluster, so I'll go ahead and create a new compute. We have dedicated or low priority. Technically, it is low priority, but I just want this done. Low priority, but don't get to compute nodes. Your job may be pre-emptied. I'm going to stick with dedicated for the time being. We're going to stick with CPU. If we go with this, it does take about an hour to run. So when I ran this, it took about an hour. So if you don't mind, it's only going to cost you 15 cents. But if you want this done a lot sooner, I'm going to try to do something a little bit more powerful. So I'm just trying to decide here, because if it only takes an hour, I might run it on something more powerful. That's 90 cents. That might be overkill, because it's not really deep learning. It's just statistical stuff. So train large data set. I wouldn't say it's large. Real-time inference and other latency-sensitive ones. How about, why is this one, I'm just looking here because this one's 29 cents. This one's more expensive, but it has 32 gigabytes of RAM. This one is 28. Oh, 14 gigabytes of RAM. Oh, it's storage. So this one's our highest in the tier. Again, you can choose this one. You just have to wait a lot longer. I just want to see if it finishes a lot faster, okay, without having to go to the GPU level, because I don't think GPU is going to help too much here. The computer name is My Diabetes Machine. Minimum number of nodes you want to provision. If you want dedicated nodes, to set the count here. Maximum, I guess I just want one node, right? We will go ahead and, complete name must be 16 characters long. Is it too long? Okay, there we go. We'll give it a moment here. Yeah, it's going to spin up the cluster. So it does take a little bit of time to start this. So I'll see you back here when this is done, okay? Great, so after a short little wait there, it looks like our cluster is running. If we double check here, we can go to compute. I believe that shows up under here, under the compute cluster. So there it is. Notice it's slightly different. This one shows you applications, and this one is just size and etc. We can click in here, see nodes and run times. We'll go make our way back here. And we'll go ahead and hit next. And notice that I think it actually will select what it generally thinks, because it'll look at your prediction value, maybe sample a bit of it and say, oh, okay, you probably want a regression thing. So to predict a continuous numeric values. So the thing is that if it was a label like text, or if it was just 0 and 1, it probably would choose classification because it's, you saw our Y value is like a number that was all over the place. It thinks it's regression. So I think that's a good indicator there. So let's go with regression. But you might want it as a binary classifier, but yeah, that's another story there. So it's as soon as we created it, it just started. It didn't give us the option to say, hey, I want to start running it. Notice on this here, it's going to do featurization. So that means it's automatically going to select out features for us, which is what we wanted to do. It's set up to do regression. We have some configuration here. So training time is 3 hours. Doesn't mean it's going to train for 3 hours, but that's, I guess, it's timeout for it. You could set a metric score threshold, so it has to meet at least this to be successful. If it's not going to do it, it probably would quit out early. Cross validations, just make sure the data is good. You can see blocked algorithms, so TensorFlow DNN, TensorFlow linear regression. If it was using DNN, so deep learning neural network, I probably would have chosen the GPU to see if it would go faster. Look at the primary metric. It's normalized root mean square error. Sometimes on the exam, they'll actually ask you, like, what's the primary metric for this thing? So it's good to take a look and see what they actually use for that. I'll probably be sure to highlight that stuff in the actual lecture content. But this will take some time to run. We have data guardrails. It will actually not populate, I guess, until we've ran it. So we'll just let it run, and I'll see you back here when it's done, okay? All right, so after a very, very, very long wait, our AutoML job is done. It took 60 minutes, so using a larger instance didn't save me any time. I don't know if maybe if I ran a GPU instance, it would be a lot faster. I'd be very curious to try that out, but not something for this certification course. So we go into here, and yeah, the cheaper instance was the same amount of time, so it probably just needs GPUs. It really depends on the type of models it's running, so we have a bunch of different algorithms in here. It ran about 42 different models. I thought last time I ran it, I saw a lot more, but you can see there's all kinds of models that it's running, and then it's going to choose the top candidate. So it chose voting ensemble. So ensemble is... we don't cover it really in the course because it gets too much into ML, but ensemble is when you actually use two different weaker models and combine the results in order to make a more powerful ML model, okay? So here we'll get some explanation. I tried this before and I didn't get really good information. So if we go here, so like I don't have anything under model performance. So this tab requires array of predicted values from the model to be supplied. We didn't supply any, so we don't get any. Data Explorer, so select a cohort of the data. All the data is we have here. So like here we were seeing age, and I guess it's just giving us an indicator about the age information. Use the slider to show descending feature importance. Select up to 3 cohorts to see the feature importance slide by side. Okay. So I guess S5 and BMI. I don't know what S5 is. We'd have to look up the data set. BMI is your body mass index. So that's a clear indicator as to what affects whether you have diabetes or not. So that makes sense. Age doesn't seem to be a huge factor, which is kind of interesting. Individual feature importance. We can go here and just kind of like narrow in and say, okay, well, why is this outlier over here? And they're like age 79, right? So it's kind of interesting to see that information. So it does give you some explanation as to why things are why they are. Over here we have a little bit more different data. This is kind of interesting. Model performance. I don't know what I'm looking at, but like here it's over mean squared, so it's that mean squared calculation there again. Okay. So yeah, it's something, right? But anyway, the point is that that we finally get metrics. So I guess we always had to click there because that makes more sense. So yeah, there's more values here. Sure. Data transformation. illustrates the data processing, feature engineering, scaling techniques, and machine learning algorithm, AutoML. So, you know, if you were a real data scientist, all this stuff would make sense to you. I think just with time, it'll make sense. But even at this point, I'm not sure. And I don't care about the model, right? If you're building something for real, I'm sure the information becomes a lot more valuable. So this model is done. And the idea is that we can deploy, oops, if we go back to the actual models. Oh, because we actually went into them, eh? So we go back to the AutoML here. I think you can deploy any model that you like. So I think you go here and deploy this. Like if you prefer a different model, you could deploy it. If we go into data guardrails, we kind of skipped over that. This is a way it does automatic featurization. So it's extracting out the feature. So how it handles the splitting, how it handles missing features. High cardinality is like if you have too much data, it might have to do dimensionality reduction. So that's just saying like, hey, if this is a problem, maybe we would do some pre-processing or stuff to make it easier to work with the data. So if we're happy with this, we can go ahead and deploy it. So let's say deploy, just say infer my diabetes. Here we have AKS and Azure Container Instance. Let's do Azure Kubernetes Service just because we did the other one here. Say diabetes prod maybe. AKS diabetes. Oh, compute name, sorry. One of the inference ones. Okay, so in order to deploy this, we would have to create our pipeline. I'm not sure if I have enough in my quota here, but let's go give it a go. So I think what it's wanting is one of these here. I think we'd want this wherever we are, right? I'm not sure where we are, if this is US East or West here. Let's go check Studio. Azure Machine Learning East West. No, I never did this when I was, I just use usually Azure Container Instance, but I'm just curious here. Say next. My diabetes. Prod. We need to choose some nodes. The number of nodes multiplied by the virtual machine's number of cores must be greater or equal to 12. Okay. No, again, if you're not confident, like if you're concerned about cost, you can just, again, watch. You don't have to do, right? This is, again, a fundamental certification. It's not super important to get all the hands-on experience yourself. But I'm just trying to explore this so we can see, right? Because I don't care about cost. It's not a big deal to me on my machine here. So probably I don't have... The system pool must use a VM SKU with more than 2 cores and 4 gigabytes. Well, what did I choose? Did I not choose the right one? We'll try this again. Oh, I chose 3. Yeah, that's fair. What did it want? 12 cores said before, I think. Valid parameters, more details. Because it already exists based on that name, eh? 2. It's giving us all this trouble, eh? This one we'll go ahead and delete. You think like it wouldn't matter, like I wouldn't have to delete it out, but that's fine. This one failed. Now what's the problem? Quota exceeded, so I can't do it because I'd have to go make a support request to increase it. So it's not a real big deal. I guess what we could do is instead of doing it on AKS, we could just deploy it to container instance if it'll let us. Notice I don't have to fill anything additional in. It'll just deploy, I think. Great. And so I guess we'll let that deploy, and I'll see you back here in a bit, okay? All right, so I'm back here checking up on my AutoML here. So if we go over to compute, we go to inference clusters. We don't have anything under there. If we go over to our experiments, under our diabetes here, because we did choose to deploy the model, right? We clicked deploy. So it should have created an ACI instance. Let's make our way over to the portal. The reason why it might not be showing up is because I'm just running out of compute. Because again, it's a quota thing. It's not a big deal for us to get it deployed. It's not like we're going to do anything with it. But yeah, so we can see that we have a container over here and it's running. So we must be able to see if we go to endpoints here. Here it is, right? I was under models. That's my problem. So pipeline endpoints, that would be something. I think that if we had deployed our designer, I thought we would have saw it under there. But here we have our binary pipeline, or our diabetes prod pipeline. So if we wanted to like test data, you know, we could pass stuff in here. I think if we wanted to kind of just like see this in action, I'm not sure if it's going to work, but we'll give it a go. So if we go into our sample diabetes data set and we just explore some of the data, we should be able to kind of select out some values, because I don't know what these values mean. So let's just say like 36. Oops, 36. But we already know that BMI is the major factor here. Sex is either 1 or 2, so we'll say 2. BMI, we'll say 25.3. The BP will be 83. Or whatever, oops, 83 here. S1, 160. S2 can be 99.6. S3, 45, 45, and 5. 5.1. Oh, we're running out of metrics here. 82. Wonder why it doesn't give us all of them. Oh, I guess it does. It's up to 6. Okay, so let's go ahead and test that, see what we get. And we got a result back, 168. So that is AutoML, all complete there for you. Yeah, so there you go. All right, so let's take a look here at the Visual Designer, because it's a great way to get started very easily with if you don't know what you're doing and you want something a little bit more advanced than AutoML and have some customization. It's great to start with one of these samples. So let's go ahead and expand it and see what we have here. We have binary classification with custom Python script, tune parameters for binary classification, multi-class classification, so letter recognition, text classification, all sorts of things. Usually binary classification is pretty easy. I'm looking for one that is pretty darn simple. Let's go take a look here. So this sample shows how to filter base feature selection to selection features. Binary classification, so how to predictors related to customer relationships using binary classes, how to handle imbalanced data sets using SMOT and modules. I'm not really worried about balancing. Customized Python script to perform cost-sensitive binary classification. Tune parameters, so you tune model parameters, best models during the training process. Let's go with this one. This one seems okay to me. And so what you can see here is that it's using a sample data set, I believe. I think this is a sample. And if you wanted to see all of them, you could literally drag them out here and do things with them. I haven't actually built one end-to-end yet for this. Again, I don't think it's like super important for this level of exam, but this just shows you that there's a pre-built one. If you start to get the handle of ML, you know the full pipeline, this isn't too confusing. So at the beginning here, we have our classification data. And then what it's going to do is say select columns in the data set. So it just says exclude column names, work class, occupation, native country. So it's doing some pre-processing there, excluding that data. It might be interesting to go look at that data set. So if we go over to our datasets tab, it should show up here, I believe. Maybe because we haven't committed or submitted this, we can't see that data set yet, but we'll look at it for a moment. Then we want to clean our data. So here it's saying clean all the columns. So custom substitution value. See if we can see what it's substituting out. It's not saying what, so clean missing data. So I'm not sure what it's cleaning out there, but because that would suggest that it's using some kind of custom script. I'm not sure where it is, but that's okay. We have split data. Pretty common to split your data, so you would have a training and test data set. It's usually really good to randomize it, so you want to randomize it, then split it. And that's just so you get better results. Then it has model hyperparameter tuning. So the idea is that it's going to use ML to figure out the best parameters for tuning. Over here, we have the two-class decision tree where it's going to do some work there. It's going to score our model, and then it's going to evaluate our model and see if it's successful. So this is all set up to go. So all we got to do is go to the top here. There's a setting wheel here, and we need to choose some type of compute. So I'm going to go here, and we have this one here, but I'm going to go create, it's for my, my diabetes one, but I'm going to go ahead and make a new one. And we're going to say, we recommend using a predefined configuration to quickly set up compute training. This one looks okay. I don't know if it needs 2 nodes, but I guess we can do this one. So we'll just say binary, we'll just say binary pipeline. Okay. Say save. Hopefully it's making a good suggestion, and we'll have to wait for that to spin up. It's going to take a little bit of time, okay? So I'll see you back here in a moment. All right, so I got a little message saying that that is ready. So what we can do, I think it was here, my notebook instance. No, that's not it. But I definitely saw a pop-up on my screen. You might have saw it too. You'd have to be paying close attention for that. But if you go over, it says that it's ready to go. So what I'm going to do is make my way back over here. We're going to select our compute. There is our binary pipeline. I'm going to select that. And there are some other options. We're not going to fiddle around with that. We're going to go ahead and hit submit. So we need a new experiment. So I'm going to just say binary pipeline. We'll hit submit. Okay, and so this is now running. So after a little while here, we're going to start seeing these go green. So this is not started. We'll give it a moment here just so we can see some kind of animation. And there it goes. It's off to the races. There's not much to do here. This is going to take a while. I don't know. I have never ran this one in particular, so I don't know if it's an hour or 30 minutes. So I'll see you back when it's done running. But yeah, it's not that fun to watch, but it's cool that you get a visual illustration, eh? So I'll see you back in a bit. I just wanted to peek in here and take a look at how it's progressing here. And you can see it's still going, and it's just cleaning the data. It's still not done. I'm not sure how long this has been running for. If we go over to our experiments and we go into our, I think it's binary pipeline, and we look at the runtime, we're about 8 minutes in. And it hasn't done a whole lot, so it's still cleaning the data. I would have thought it'd be a little bit faster. I'm kind of used to using like AWS, and it goes, SageMaker's, this doesn't usually take this long. But I mean, it's nice that it's going here, but yeah, so we're almost out of the pre-processing phase. We'll be on to the model tuning, okay? All right, so after waiting a little while, it looks like our pipeline is done. So if we make our way over to experiments and you go to binary pipeline, we can see that it took 14 minutes and 22 seconds. We can go here and just see some additional information. There's nothing really else to see. We saw all the steps already ran, so you can see them all here. Okay, and so let's say we wanted to, there's nothing under metrics, but enable metrics, log data points, compare these within across runs. We only did a single run, so there's nothing to compare. So let's say we're happy with this and we want to deploy this model. Well, what I'm going to do is go back to the designer, click back here, and so now in the top right corner, we can create our inference pipeline. So I can't remember if submit's going to run it. I don't want to run it again. I just want to go ahead and create ourselves a real-time or batch pipeline. Let's say real-time pipeline here. And what this will do is it'll actually create a completely different pipeline. So here's a completely new one, but it's specifically designed to do deployment, okay? So this is now, one was for training the model, and this one is actually for taking in data and doing inference, okay? So what we can do is we can go ahead and just submit this. And so we'll put this under our binary pipeline here. We'll go ahead and hit submit. And I believe that we need a different kind of compute here. I'm surprised that it's even running. No, I guess it has a compute there. So it's going to run, and once it finishes running, then I believe that we can go ahead and deploy it. Okay, so let's just wait for that to finish. All right. All right, so after a little while there, we've ran our inference pipeline, and so it's definitely something that is ready for use. The idea is that when we actually use it, it's going to go through this web service input to this web service output, but not so important at this level of certification. Let's see what it looks like to go ahead and deploy it. So we have the option between a real-time endpoint and an existing endpoint. We don't have an endpoint yet, so we'll just say binary pipeline. Okay, and notice we have the option between, it wants it lowercase, binary pipeline. And we have the option between Azure Kubernetes Service and Azure Container Instance. It's a lot easier to deploy, I think, to Container Instance. And we'll be waiting forever for Kubernetes to start up. So we're going to do Container Instance. We have some options like SSL and things like that. Not too worried about it. So we're just going to go ahead and hit deploy. Okay. And so that is going to go ahead and deploy that. So we'll wait for this real-time inference. If we go over to our compute, it should spin up. So this is for AKS. So I don't know if it will show up here. I think I've seen things under here, but I think this will be for Azure Kubernetes Service. And I don't think we're going to see it show up under there. However, we do not need to be running this anymore, so we'll go ahead and delete the binary pipeline because we don't have it for any use right now, and we might need to free it up for something else. Okay, so go ahead and delete it. We don't need it. And coming back to our pipeline, our designer here, I'm just trying to see where we can keep track of it. Well, I know it's deploying, so waiting for real-time endpoint. So I'll see you back here when this is done, okay? It just takes a little bit of time. All right, so I think our pipeline is done. If we make our way over to endpoints, there it is, the binary pipeline. If we wanted to go ahead there, we could test the data. And so it actually already has some preloaded data for us. If we hit test, it's nice that it fills it in, eh? We get some results back, okay? So, I mean, and then we see like scored labels and income and score probability. So things like that, that is useful. So it's giving back all the results, but I don't think it has. Yeah, it doesn't have scored labels and scored probabilities, which is the value we want to come back here. So there are our endpoints, and that is the end of our exploration with Designer, okay? All right, so let's take a look at what it would be to actually train a job programmatically through the notebook. So remember, we saw these samples over here, and so we saw this image classification MNIST, and this is a very popular data set for doing computer vision. These are really great. If you want to really learn, you should really go through these and just read through them because they're probably very, very useful. I've done a lot of this before, so for me, it's not too hard to figure out, but I've actually never ran this one, so let's run it together. Again, we want to be in Jupyter Lab, so you can go here and click it there, or go to the compute if it's being a bit finicky, and just there, we'll get a tab open here, and we'll see how this goes. So what I want to do is just make sure we're back here. I'm going to click into this one, and we have a few. So there's part 1, and then we have the deploy stage. So let's look at training. I don't know if we really need to deploy, but we'll give it a read here. So in this tutorial, you train an ML model on a compute resources. You'll be training and deployment workflow via the Azure Machine Learning Service in a notebook. There's 2 parts to this. This is using the MNIST dataset and scikit-learn. And with Azure Machine Learning, probably the SDK, it's a popular data set with 70,000 grayscale images. Each image is handwritten digits of 28 times by 28 times pixels, representing numbers from 0 to 9. The goal is to create multi-class classifier to define the digits in a given image that represents. So we're going to learn a few things here, but let's just jump into it. So the first thing is that we need to import our packages. So here it does that matplotlib inlines. Just make sure that when we print things that we visually see them. We're going to need NumPy and then matplotlib itself, the Azure ML core, and then we're going to import a workspace since we'll need one there. And then I guess it just checks the version, making sure if we have the right version here. Okay, so this is 1.28.0. It's pretty common, even this in AWS, they'll have like a script in here to update it in case it is out of date. I'm surprised it didn't include it in here, but that's okay. We'll scroll on down. And by the way, we're using Python 3.6 Azure ML. If this is the future, you know, they might retire the old one. You're using 3.8, but you know, it should generally work if it's in their sample data set. I assume they try to maintain that, okay? So connect to a workspace. So create a workspace object from an existing workspace. Reads the file config.json. So what we'll do is go run that. I assume it's kind of like a session. And so here it says it's found our workplace. So really it's not creating a workspace, it's just returning the existing one so that we have it as a variable here. Create an experiment. So that's pretty clear. We saw experiments in the AutoML and the designer. So we'll just hit run there. Okay. So we named it Core ML and we said experiment. I wonder if it actually created one yet. Let's go over to experiment and see if it's there. So it is there. Cool. That was fast. I thought it would like print something out, but it didn't do anything there. So create or attach an existing compute resource by using Azure Machine Compute, a managed service, data scientists, etc., yada, yada, yada. So create a compute, creation of a compute takes about 5 minutes. So let's see what it's trying to create. So we have some environment variables that it wants to load in. I'm not sure how these are getting in here. I'm not sure where environment variables are set in Jupyter, or even how they get feeded in, but apparently they're somewhere. But we have, it doesn't matter because these are defaulting. So here it says CPU cluster 0 and 4. It's going to use a standard D2 V2. That is the cheapest one that we can run. I kind of want something a little bit more powerful just for myself, just because I want this to be done a lot sooner. But again, you know, if you don't have a lot of money, just stick with what's there, okay? So, and this is CPU cluster. So if we go here, I just want to see what our options are. Not sure why it's not showing us options here. You don't have enough quota for the following VM sizes. So it's because I'm running more than one VM right now. Yes, I've hit my quota. Okay, so like I probably would have to request for more. So I think this is the one I'm using. What's the difference here? This standard DV2 vCPUs. It's the same one, right? So request quota increase. I don't know if this is instant or not. I'd have to make a support ticket. Oh, that's going to take too long. So the thing is that because the reason is that I'm running the AutoML and the design and the designer in the background here, trying to create all the workshops or the follow-alongs at the same time. But what I'll do is I'll just come back, and when I'm not running one of those other ones, then I will I'll come back here and continue on. But we're just here at the step. We want to create a new compute. Okay. All right, so I'm back and I freed up one of my compute instances. If I go over here now, I just have the one cluster instance for my AutoML. But what we'll do here is, again, just read through this. So this will create a CPU cluster, 0 to 4 nodes, standard D2 V2. I guess we'll just stick with what is here. Just reading through here, it looks like it tries to find the compute target. It's going to provision it. It will create the cluster, call pool for minimum numbers of nodes for a specific time, so wait for completion. So we'll go ahead and hit play. And so that's going to go and create us a new cluster. So we're just going to have to wait a little while here for it to create, about 5 minutes, and I'll see you back here in a moment. All right, so the cluster started up. If we go back over here, we can see that it's confirmed. I don't know why it was so quick, but it went pretty quick there. So we're on the next section here, explore the data. So download the MNIST dataset, display some sample images. So it's just talking about it being the open dataset. The code retrieves in the file dataset object, which is a subclass of dataset. File dataset references a single or multiple files of any format in your data store. The class provides you with the ability to download or mount files to your computer by creating a reference to the data source location. Additionally, you register the dataset to your workspace for easy retrieval during training. There's a bit more how-tos, but we'll give it a good read here. So we have the open dataset MNIST. It's kind of nice that they have that reference there. So we have a data folder. We make the directory. We are getting the dataset. We download it, and then we are registering it. So let's go ahead and run that. Not sure how fast that is. Shouldn't take too long. As it's running, we'll go over here to the left-hand side, refresh, and we'll see if it appears. Not as of yet. There it is. Go into here, maybe we explore the data. I'm not sure how it would look like, because these are all images, right? Yeah, so they're in ubyte GZ, so they're in compressed files. We're not going to be able to see within them, but they're definitely there. We know they're there. So that is now registered into our data set. Display some sample images, so load the compressed into files into NumPy, then use matplotlib. Plot 30 random images from the data set from above. Note the step requires load data function. It's included in the utils.py. This file is included in the sample folder. We have it over here. We just double click. Very simple file to load data. And we'll go ahead and run that. And it's pretty simple here. So load data, xtrain, xtest. Are we setting up our training and testing data here? It kind of looks like it because it says train and test data. That's when we usually see that kind of split. And again, it's doing a random split, so that sounds pretty good to me. Let's show some randomly chosen images. Yeah, so I guess they do set up the training data here. And then down below, we're actually showing the images. So here's some random images. Train on a remote cluster. So for this task, you submit the job to run on the remote training cluster to set up earlier. Submit your job. Create the directory, create a training script, create a script for run configuration, submit the job. So first we will create our directory. And notice it created this directory over here, because I guess it's going to put the training file in there. And so this will actually write to a training file. This makes quite a bit of sense. So if we click into here, it should now have a training file. We'll just give it a quick read, see what's going on here. So a lot of times when you create these training files, you have to do, and this is the same if you're using AWS, like when you're creating or SageMaker, you create a train file, because it's part of frameworks. It's just how the frameworks work, but you'll have these arguments. So it could be like parameters to run for training, and there could be a whole sorts of ones here. Here they're loading in the training and testing data. So it's the same stuff we saw earlier when we were just viewing the data. Here it's doing a logistic regression. It's using linear, maybe a linear learning model there. It's doing multi-class on that there. And so what it's going to do is fit. So fit is actually performing the training. And then what it's going to do is make a prediction on the test set. Then we're going to get accuracy. So we're getting kind of a score. So notice that it's using accuracy as a evaluation metric, I suppose, right? And then at the end, we're going to dump the data. A lot of times, like, you have to save the model somewhere. So they're outputting the actual weights of the neural network and all other stuff. It's a PLK file. I don't know what that is. But if you're using like TensorFlow, you would use TensorFlow serving at the end of this. A lot of times frameworks will, like PyTorch or TensorFlow or MXNet, they'll have a serving layer. But since we're just using scikit-learn, which is very simple, it's just going to dump out that file into our outputs. This is going to probably run a container, so this outputs isn't going to necessarily be on the outputs into here. It's more like the outputs of the container. And a lot of times the container will then place this somewhere. So like it'll be saved on the container, but it'll be passed out to the register or something like that, like model registry. So anyway, we ran this, and so that generated the file. We don't want to keep on running this multiple times. I probably would just overwrite the file, so it's not a big deal. Here it says, notice how the script gets saved in the data model. So here it's saying the data folder. I guess we didn't look at that. So we go top here. I didn't see, this is data folder. Wasn't really paying attention to where that was. I guess it looks like where more so it's loading the data in. So here it saves the data output. Anything written to this directory is automatically uploaded to your workspace. So I guess that's just how it works. So it probably will end up in here then. So util.py reference the training script to load the data set correctly and copy the file over. So we will run this to copy the file over. So I'm guessing, did it put it into here? I'm just wondering, yeah, so it just put it in there because when it actually packages it for the container, it's going to bring that file over because it's a dependency. So configure the training job. So create a script run config, the directory that contains the script, the compute target, the training script, training file, etc. Sometimes, like in other frameworks, they'll just call them estimators, but here it's just called a script run config. So I'm just trying to see what it's doing. So scikit-learn is the dependency. Okay, sure, we'll just hit run. Okay. And then down below here, we have script run config. So it looks like we're passing our arguments. So we're saying this is our data folder, which is apparently here. We're mounting it. And then we're setting regularization to 0.5. Sometimes you'll pass in dependencies in here as well. I guess these are technically our parameters that are getting configured up here at the top, right? But sometimes you'll have dependencies if you're including other files here. And I guess that's up here, right? So see where it says environment, and then we're saying include the Azure ML defaults and the scikit-learn and stuff like that. And so then it gets passed in the env. So that makes sense to me. We haven't ran that yet because we don't see any number here. Submit the job to the cluster. So let's go ahead and do that. So it says it returns a preparing or running state as soon as the job is completed. So it's in a starting state. Monitor remote run. So in total, the first run takes 10 minutes, but the second run is as long as the dependencies in Azure ML environment don't change. The same image is reused, and hence the start time is much faster. Here's what's happening while you wait. The image creation, a Docker image is created matching the Python environment specified by the Azure ML environment. The image is built and stored in the ACR, the Azure Container Registry, associated with your workspace. Let's go take a look and see if that's the case. Because sometimes like resources aren't visible to you, so I'm just curious, do we actually see it? Okay. And yep, there it is. Okay, so they did not lie. So associated with your workspace, image creation uploading takes about 5 minutes. This stage happens once for each Python environment. Since the containers cache subsequent runs during image creation, logs are stemmed to the run history. You can monitor the image creation process using these logs, wherever those are. If the remote cluster requires more nodes to execute the run than currently available, additional nodes are added automatically. Scaling typically takes about 5 minutes. And I've seen this before, where if you're in your compute here, sometimes it'll just say like scaling because it's just not enough. So running in the stage, the necessary scripts and files are sent to the compute target. Then the data stores are mounted, copied. The entry script is run. So the entry script is actually the train.py file. While the job is running, ST out in the files is in the logs directory or stemmed to the run history. You can monitor the run's progress using these logs. The .outputs directory of the run is copied over to the run history in your workspace so you can access these results. You can check the progress of a running job in multiple ways. This tutorial uses the Juypter widget. So it looks like we can run this, watch the progress. So maybe we'll run that. And so it's actually showing us the progress. That's kind of cool. I really like that. So it's just a little widget showing us all the things that it's doing. Let's go take a look and see what we can see under our experiments and our run pipeline. Because it was talking about things like outputs and things like that. So over here in the outputs and logs, I'm just curious as if this is the same thing. I'm not sure if this this tails. Yeah, it does tail. It just moves. So we can actually monitor it from here. I guess that's what it was talking about. So here we can see that it's setting up Docker. It's actually building a Docker image. And then I'm not sure, did it send it to, I mean, it's on ACR already, I think. It looks like it's just still downloading, extracting packages. So maybe it's actually running on the image now. So we'll just wait there. We pop back over here. You know, we can see probably the same information. Is it identical? Yeah, it is. So we're 3 minutes in. It's probably not that fun to watch it in real time and talk about it. So let's just wait until it's done. I'll see you back then, okay? All right, so I'm about 17 minutes in here. I'm not seeing any more movement here, so it could be that it is done. It does say if you run this next step here, it will wait for completion. Specify show output to true for a verbose log. So here, actually it did output a moment ago, so maybe it actually was done. I just ran it twice, so I'm not sure if that's going to cause me issues there. So, because I can't run the next step unless I stop this. Can I individually cancel this one here? I think I can just hit interrupt the kernel. There we go. Okay, so I think that it's done. Okay, because it's 18 minutes in, and I don't see any more logging in here. It's just not very clear. And also the logs, we just have a lot of stuff going on here. Like it's just so much. So, you know, if we were keeping pace, we probably just would have saw all these created. Yeah, so we just had a few more outputs there. But I think that it's done. Okay. It's just there's nothing definitively saying like done. Do you know what I'm saying? And then up here, it doesn't say, oh, I guess it does say that it's done. All right. So yeah, I just never ran it with this tool, so I just don't know. So I guess it does definitively say that. I already ran this, so we don't need to run that again. I just feel like we'll get stuck there. So let's take a look at the metrics. So regularization rate is 0.5. Accuracy is 9. So 9 is pretty good. The last step is train the script wrote in the output sklearn. I want to see if it's actually in our environment here. I don't think it is. So outputs is somewhere. It's in our workspace somewhere, but it's just not, we just don't, oh, it's right here. Okay. So it outputted the actual model right there. And so you can see the associated files that are ran. Okay, we'll run it. Register the work model in space so you can work with other collaborators. Sure. So if I click on that here and we go back over to our models, it is now registered over here. Okay. And so we're done part 1. I don't want to do all these other parts. Training is enough as it is, but let's just take a look at the deploy stage. Okay, so for prerequisites, we're setting up a workspace. We are loading our registered model. Okay, we register it. We have to import packages. We are going to create scoring script, deploy to an ACI model, test the model. If you want to do this, you can go through all the steps. It does talk about a confusion matrix, and that is something that can show up on the exam, is actually talking about a confusion matrix, but we do cover that in lecture content, so you generally understand what that is. But you know, I'm too tired. I don't want to run through all this, and there's not a whole lot of value other than reading through it yourself here. So I think we're all done here, okay? Okay, one service we forgot to check out was data labeling. So let's go over there and give that a go. So I'm going to go ahead and create ourselves a new project. I'm going to say my labeling project. And we can say whether we want to classify images or text. We have multi-class, multi-label, bounding box, segmentation. Let's go with multi-class. I'll go back here for a second. Multi-class, whoops. I don't know if we create a data set, but we could probably upload some local files. Let's say my Star Trek dataset. It doesn't let us choose the image file type here. It'd be nice if these were images. It's going to tell us what here. It's very finicky, this input here. File dataset references a single or multiple files in your public data store or private public URL. Okay, so we'll go next. If we can upload files directly, that'd be nice. Ooh, upload a folder. I like that. So what we'll do is we do have some images in the free AI here under Cognitive Services, Assets. We have, we'll go back here and we'll say, I think objects would be the easiest. Oh, but we just want a folder, right? So yeah, we'll just take objects. Yep, we'll upload the 17 files. Yep, we'll just let it stick to that path. That seems fine to me. We will go ahead and create it. And so now we have a data set there. We'll go ahead and select that data set. We'll say next. Your data set is periodically checked for new data points. Any data points will be added as tasks. It doesn't matter. We're only doing this for test. Enter the list of labels. So we have TNG, DS9, Voyager, toss. That's the types of Star Trek episodes. Label which Star Trek series the image is from. Say next. I don't want enabled, but you can have enabled assistant labeler. I'm going to say no. We'll create the project. Okay, and I'll just wait for that to create, and I'll see you back here in a moment, okay? All right, so I'm back here. Actually, you didn't have to wait long. I think it instantly runs. I just assumed like I was waiting for a state that says completed, but it's not something we have to do. So we have 0 out of 17 progress. We're going to go in here. We're going to go label some data. We can view the instructions. It's not showing up here, but that's fine. If we go to tasks, we can start labeling. So what season is this from or series? This is Voyager. We'll hit submit. This is Voyager. We'll hit submit. This is TOS. We'll hit submit. This is TNG. This is TNG. This is DS9. DS9. Voyager. Voyager. TNG. DS9. You get the idea though. And you got some options here like change the contrast if someone can't see the photo or rotate it. This is Voyager. Voyager. TNG. DS9, Voyager, Voyager, and we're done. So we'll go back to our labeling job here. We'll see we have the breakdown there, and now our data set is labeled. We can export our data set, CSV, Coco, Azure ML data set. I believe that means it'll go back into the data sets over here, which will make our lives a little bit easier. We'll go back to data labeling. Okay. So you just granted people access to the studio, they'd be able to just go in here and jump into that job, okay? If we go over to the data set, I believe we should have a labeled version of it now. So my labeling project. So I believe that is the labeled stuff here, right? Yeah, so it's labeled. So there you go, we're all done Azure Machine Learning, and so all that's left is to do some cleanup. Okay, so we're all done with Azure Machine Learning. If we want to, we can go to our compute and just kill the services we have here. Now, if we go to the resource group and delete everything, it'll take all these things down anyway, but I'm just gonna go, I'm a bit paranoid, so I'm gonna just manually do this, okay? Hit delete. Okay, and so we'll go back to portal.azure.com. And I'm going to go to my resource groups. And everything is contained. It should be all contained within my studio. Just be sure to check these other ones for that. And we can see all the stuff that we spun up. We'll go ahead and hit delete resource group. I don't know if it includes like, because I don't see like container registry, right? So I know like it puts stuff there. I guess it does. This is container registry. So that's pretty much everything, right? And I'll take down everything. So, and if you're paranoid, all you can do is go to all resources and double check over here, because if there's anything running, it will show up here, okay? But that's pretty much it. And so just delete and we're all done.